MyBatis Architecture. Here you can see MyBatis architecture diagram. MyBatis is a Java persistent framework that couples objects with stored procedures or SQL statements using an XML descriptor or annotations. Here you can see the MyBatis architecture diagram. MyBatis is a persistent framework which automates the mapping between SQL database and objects in Java, .NET and Ruby on Rails. In Java, the objects are POJOs, plain old Java objects. The mappings are decoupled from the application logic by packaging the SQL statement in XML configuration files. The result is significant reduction in the amount of code that the developer needs to access in a relational database using lower level APIs like JDBC and ODBC. Other persistent frameworks such as Hibernate allow the creation of an object model in Java, say by the user, and create and maintain relational database automatically. MyBatis takes the reverse approach. The developer starts with an SQL database, and the MyBatis automates the creation of the Java objects. Both approaches have advantages, and MyBatis is a good choice when the developer does not have the full control over the SQL database schema. For example, an application may need to access existing SQL database used by the other software, or access new database when schema is not fully under application developer's control, such as when a specialized database design team has created the schema and carefully optimize it for high performance. On May 21st, 2010, the development team decided to move from ASF to Google Code, with changing the project name to MyBatis. Here you can see a configuration is connected to map annotations. Here configuration is connected to SqlMapConfig.xml. SqlMapConfig.xml is connected to SqlMap.xml files. This part is configuration is connected to mappers. Mapper is connected to mapped statements, HashMap, dictionary, Java, .NET object, primitive, simple, int, string data are connected to mapped statements. Map statements are connected to HashMap, dictionary, Java, .NET objects, and primitive, simple, int, string date. Map statements are connected to RDBMS here. This diagram shows MyBatis .NET data mapper workflow. Here you can see data map definition file, SqlMap.config. Here SqlMap.xml is connected to SqlMap.config. SqlMap.config is connected to SqlMap statements. Here parameter objects so here hash table, .NET object, primitive object, int, string, etc. and in parameter objects. Here hash table and .NET object and primitive object, int, string, etc. are connected to SqlMap statements. and SQL map statement is connected to here hash table .NET object and primitive object int string etc. Hash table .NET object and primitive objects int string etc. are in result objects. Here SQL map statement interact with ADO, interact with databases via ADO.NET here. Here you can see MyBatis architecture in a different view. Here MyBatis one here MyBatis configuration SqlMapConfig.xml. This document is used as an overall configuration file of MyBatis, and it is configured with the information such as MyBatis operating environment. Mapper.xml file is the SQL mapping file, which is equipped with a SQL statement that operates the database. This document need to be loaded in SqlMapConfig.xml to construct SQL session factory. Construct SQL session factory as a conversation factory through MyBatis environment and other configuration information. The conversation factory creates a SQL session as soon as possible, and the operation database needs to be carried out through SQL session. For the bottom layer of MyBatis has defined the executor interface operation database. The executor interface has two implementation. One is basic executor and the other is the cache executor. 5 map statements. Map statements is also a bottom packaging object of MyBatis, which contains MyBatis configuration information and SQL mapping information. In the mapper.xml file, the SQL corresponds to the map statement object, and the ID of SQL is the ID of map statement. 6 map statements. Map statements define the input parameters of execution, including HashMap, basic type POJO, and executor. And the executor map the input of the Java object into SQL before executing SQL through map statements. The input parameter mapping is the prepared statement setting parameters in the JDBC program. 7 map statement defines the output results of SQL execution, including HashMap, basic type POJO, and the executor map the output result into a Java object after performing SQL through map statements. The mapping process of the output result is equivalent to the analysis and processing of the results of the JDBC programming process. Here you can see SqlMap.Config.xml and Mapper1.xml, Mapper2.xml, Mapper3.xml, Mapper.xml are in MyBatis. here mappers and mapper XMLs and SqlMapConfig.xmls you can in MyBatis here you can see it. Then here this is MyBatis configuration. MyBatis configuration is connected to SQL session factory. SQL session factory is connected to SQL session. SQL session is connected to executor. Executor is connected to mapped statement. Input parameters. Here map, string, integer, etc. and POJO are inside input parameters. Input parameters are connected to map statement. Map statement is connected to output results. Map, string, integer, etc. POJO and list are in output results. Map statement is connected to database here. Here you can see MyBatis persistence layer model. MyBatis is currently a very popular semi-ORM framework. Unlike Hibernate, which is an ORM framework that assembles SQL through APIs, MyBatis does not provide developers with the ability to interact with the database purely by manipulating objects. It is a template. It is a template implemented through XML that stored SQL statements and provide interactive functions for the application layer. MyBatis provides the problem. MyBatis avoids the problem that Hibernate has difficulty building complex SQL through API. The MyBatis model is shown in this figure. MyBatis parses and generates SQL according to the specified annotations, interfaces, and SQL templates. The application layer calls the POJO object corresponding to the database table and executes the corresponding method. The bottom layer of the method will match the corresponding SQL statement and execute it. After the database execute the SQL and transform the return result to meet the needs of the application layer. Due to the adopted SQL template, the complex queries rely more on the user logic. MyBatis uses SQL development workload and database portability concessions to provide greater free space for the system design, and MyBatis also provide powerful and flexible dynamic SQL syntax support. MyBatis itself also provides the cache function. The MyBatis framework integrates a variety of operational relational data concepts and methods. MyBatis does not over encapsulate the underlying JDBC. Compared with Hibernate, MyBatis is more flexible, lightweight, and better performing semi-automatic ORM framework. Here, application program interacts with POJO. POJO interacts with mapper. Annotation, interface, and SQL templates are inside mapper. Annotations and interface interacts with the SQL templates. and and the mapper interacts with DB. Here you can see MyBatis overall layered architecture. As a semi-automatic ORM framework based on SQL templates, MyBatis is a template implemented through XML that combines parameters, filling, data type conversion, and dynamic SQL to quickly and flexibly design SQL that meets various business needs. From the perspective of layered architecture, MyBatis as a whole is divided into 3 layers, namely the interface layer, the core layer, and the basic layer as shown in this figure. The interface layer mainly includes related APIs of a SQL session. SQL session defines the API provided by MyBatis to the application layer and serves as a bridge between application layer and MyBatis. When the interface receives the call request, it will call the corresponding module of the core processing layer to complete the specific database operation. API cannot only directly face program developers, but also serve as the underlying API for interacting with the database. In combination with dynamic proxy, developers can use methods in mapper interface. The core layer is mainly responsible for processing configuration modules, SQL analysis, parameter mapping, conversation, SQL execution, result set conversion, and other functional modules. This layer can read the configuration files and SQL modules set by the developer and analyze and cache them. The interfaces modified by the mapper annotations are dynamically proxied to generate actual proxy object, and the actual interface functions are enhanced through the proxy objects to implement functions such as parameter filling, SQL execution, and result set conversion. The base layer mainly includes tools, methods, and modules that support core processing. Support the core processing layer, including XML parsers, transaction modules, reflection modules, type converters, log modules, and cache modules. Here you can see a SQL session is inside the interface layer. Here parameter mapping, configuration analysis, result set mapping, SQL execution, SQL analysis and plugin are inside core layer. Reflection, parameter transition, cache, transaction, DB source, resolver, resource load and log are inside base layer. Here you can see MyBatis core component model. MyBatis framework mainly includes 4 core components, namely constructor, session factory, session interface, and mapper. The session interface and mapper are the most important component of MyBatis, and session interface is SQL session. This SQL is executed concurrently. The mapper consists of an XML file, namely SQL template, and Java interface. It is responsible for recording mapping rules, configuring caches, saving SQL related information, dynamic SQL, and session transaction control. The implementation steps performed by the persistent layer framework MyBatis are as follows. 1. MyBatis will get the specified configuration file, get the specified configuration file path through the constructor, read the MyBatis main configuration file, and the SQL template file, and pass them, and generate a mapper proxy factory. And generate a mapper proxy factory object for each mapper interface, and cache it in the MyBatis global configuration object config. When an interface is used, the interface is used to dynamically proxy the interface. 2. MyBatis will pass the SQL template file corresponding to mapper interface, pass the input parameter type, dynamic SQL and result type information into SQL source objects, encapsulate it as a mapped statement object, cache it in the configuration object config, and add the mapper interface path to the method. The name string is used as the key value of the mapped object. Then session factory is obtained through the constructor, and the session object SQL session is obtained, which is used to call the persistence layer method. 3. When the mapper interface proxy object is obtained, through SQL session or the proxy interface is injected into the IOC container through the mapping scan configurer when integrating with the Spring. MyBatis find corresponding mapper proxy factory object in the global configuration object config through the mapper path method both in as a parameter. Mapper proxy factory returns the actual proxy object after dynamic proxying of the mapper interface. 4. When the corresponding method is executed through the proxy object, the method that is actually enhanced by the dynamic proxy is actually executed. The parameter corresponding to the method are used to find the mapped statement object corresponding to the method from the global configuration object corresponding to the method from the global configuration object, and the parameters are compiled. Post population generates and execute the SQL and returns the return result set after conversion according to the rules of the mapper. Here SQL session factory creates a SQL session out of a connection or a data source. Here SQL interface SQL session, the primary Java interface for working with MyBatis. Through this interface you can execute commands, get mappers and manage transactions. Here MyBatis-config.xml and SqlMapper are connected to SQL session factory builder via pass. Here XML and mapper are inside SqlMapper. XML and mapper, XML interacts with mapper, and here SQL session factory builder is connected to configuration via register. Here SQL session factory builder is connected to SQL session factory via builder. SQL session factory is connected to SQL session via get, and here configuration interacts with mapper statement. Mapper statement is connected to SQL session via proxy. SQL session is connected to DB via execute. Here you can see architectural levels of components. This is another architecture diagram of MyBatis. From the perspective of MyBatis code implementation, the main components of MyBatis are as follows. SQL session as the main top level API for MyBatis work. It represents the session that interacts with the database and completes the necessary database addition, deletion, modification, and query functions. Executor. MyBatis executor is the core of the MyBatis scheduling, responsible for the SQL statement generation and query cache maintenance. Statement handler encapsulates the JDBC statement operation and is responsible for operation of JDBC statements such as settings parameters and converting the statement result set into a list set. Parameter handler responsible for converting the parameters passed by the user into the parameters required by the JDBC statement. Result set handler responsible for converting the result set object returned by JDBC into the collection of type list. Type handler responsible for mapping and conversion between Java data types and JDBC types. Mapped statement maintains the encapsulation of the select, update, delete, insert node. SQL source responsible for dynamically generating SQL statement based on the parameter object passed by the user, encapsulating the information in bound SQL object and returning it. Bound SQL represent the dynamically generated SQL statement and corresponding parameter information. Configuration, all configuration information of MyBatis is maintained in the configuration object. Here configuration layer. Configuration layer determines how MyBatis works. MyBatis provides two configuration methods. Based on XML configuration and Java API based approach. SQL Session Factory Builder will create SQL Session Factory according to the configuration. SQL Session Factory is responsible for creating SQL sessions. Interface layer. Interface layer is responsible for the way of interacting with the database. There are two ways to interact between MyBatis and the database. Uses SQL session. SQL session encapsulates all SQL execution statement obtained the mapper and manages the transaction method. Users only need to pass this in the statement ID and query parameters to the SQL session object, and they can interact with the database easily. The disadvantage of this approach is that it does not confirm the paradigm of object-oriented programming. 2. Uses the mapper interface. MyBatis will generate a mapper instance through the dynamic proxy mechanism according to the method information declared by the corresponding interface. MyBatis will determine the statement ID according to the method name and parameter type of this method, and then map it with the SQL session. The bottom layer interact with the database is completed through SQL session. Data processing layer. The data processing layer can be said to be the core of MyBatis. In a big way, it has to complete two functions. According to the past parameter statement and parameters, dynamic statement generation can be said to be very elegant design of the MyBatis framework. MyBatis uses OGNL to dynamically construct SQL statement through the parameter values passed in, making MyBatis highly flexible and extensible. Parameter mapping refers to the conversion between Java data type and JDBC data type. There are two processes here. In the query phase, we need to convert Java type data into JDBC type data through prepared statement dot set xx method, set the value, and the other is to convert the JDBC data type of the result, set query result into Java data type. 2. Execute SQL statement and processes the response result set. After the dynamic SQL statement is generated, MyBatis will execute the SQL statement and convert the result set that may be returned into a list. In the processing of the result set, MyBatis supports supports one-to-many and many-to-one conversions of the result set relationship, and there are two supports methods. One is the query of the nested query statement, and the other is the query of the nested result set. Frame support layer. First, transaction management mechanism. MyBatis abstract the transaction into transaction interface. Transaction management of MyBatis is divided into two forms. Use the JDBC transaction management mechanism, that is the use of java.sql.connection object to complete the commit, rollback, close, etc. of the transaction. Use manage transaction management mechanism. MyBatis does not implement transaction management by itself, but allow program container such as JBoss WebLogic to achieve transaction management. 2. Connection pool management. 3. SQL statement configuration supports two ways: XML configuration and annotation configuration. 4. Cache mechanism. MyBatis adopts two-level cache structure. Level 1 cache is the session level 1 cache, is also called local cache. And L2 cache is the application level cache. The user configured the cache enable equal true to enable the L2 cache. Here you can see a configuration layer. Configuration here you can see SQL session factory builder is connected to SQL session factory, and configuration layer is connected to interface layer. Here mapper interacts with SQL session. Select XXX, insert, update, delete, flush statements, clear cache, close, commit, and rollback are connected to SQL session. Here data processing layer, parameter handler, SQL source, executor, and result set handler are inside data processing layer. Data processing and here parameter handler is connected to SQL source, and SQL source is connected to executor, and executor is connected to result set handler. Here you can see a frame support layer. Here you can see cache mechanism. MyBatis adopts two-level cache structure. Level 1 cache is session level cache. Level 1 cache is session level cache. Level 1 cache is also called local cache. Generally speaking, a SQL session object will use executor object to complete session operation, and executor object will maintain a cache to improve query performance. The lifecycle of a first level cache is at the session level. L2 cache is application level cache. The user configures cache enabled equal true to enable the L2 cache. If the second level cache is enabled, SQL session will first use the caching executor object to process query requests. Caching executor will check whether there is a matching data in the second level cache. If there is a match, it will directly return the cache result. If it is not in the cache, it will be handled over to the real executor object to complete the query, and then caching executor will place the query result returned by the real executor to the cache and then return to the user. The life cycle of the secondary cache is application level. Here SQL session executor and caching executor map state configuration are inside MyBatis. Here SQL session interacts with executor. Executor interacts with executor interacts with here DB. For example, DB MySQL, Oracle, H2, Postgres, DB2, etc. SQL session interacts with caching executor, and executor interacts with caching executor. Caching executor interacts with configuration. Maps statements are inside configuration, and cache is inside mapped statements. Here namespace 1, namespace 2, namespace n, etc. And here mem, you can see here mem cache, cache, etc. Now we are considering the scope of our description. So here you can service and repository mapper are in application modules. Service is connected to repository mapper. MyBatis 3 and MyBatis Spring are in OR mapper. Repository mapper is connected to MyBatis 3. Here we are considering in this presentation MyBatis 3 basically. MyBatis 3 is connected to JDBC basic APIs and data source. JDBC basic APIs and data source are in JDBC interfaces. Configuration for connect is in data source. In data source, JDBC basic API and data source are connected to JDBC driver. JDBC driver is in JDBC implementations. JDBC drive is connected to database. Database is in persistent layer. Database Oracle, DB2, Postgres, SQL, and more. Here you can see the relationship of MyBatis 3 components. The explanation about main components of MyBatis 3 configuration file is given below. In MyBatis 3, the SQL execution and OR mapping is implemented by integrating the following component with each other based on the definition of configuration file. MyBatis configuration file, XML file that explain operation settings of MyBatis 3. It is a file that explains the details such as connecting destination for database, path of mapping file, operation settings of MyBatis, and so on. It is not necessarily to specify connection destination of database and mapping file, path settings in the configuration file. When using it by integrating with Spring, however, the settings are performed when changing or extending default operations of MyBatis 3. org.apache.ibbatis.session.sql session factory builder, a component to read MyBatis configuration file and generate SQL session factory. This component is not directly handled by the application class when used by integrating with Spring. org.apache.ibatis.session.sql session factory, a component to generate SQL session. This component is not directly handled by the application class when used by integrating with Spring. org.apache.ibatis.session.sql session, a component to provide API for SQL execution and transaction control. It is the component that plays the most important role when accessing database using MyBatis 3. When this component is used by integrating with Spring, it is not directly handled by the application class. Mapper interface, an interface to call the SQL defined in mapping files typesafe. Mapping file in typesafe. Developer needs to create only the interface, as MyBatis 3 automatically generates an implementation class for the mapper interface. Mapping file, XML file that explains SQL and OR mapping settings. Flow by which main components of MyBatis 3 access the database is explained here. Process for accessing database can be broadly divided into two types. Processes that are performed at the start of the application. Processes 1 to 3 mentioned in this here correspond to this type. Processes that are performed for each request for the client. Processes 4 to 10 mentioned here correspond to this type. Processes that are performed at the start of the application are executed with following flow. So the number 1, application request building SQL session factory for SQL SQL session factory for SQL session factory builder. 2, SQL session factory builder reads MyBatis configuration file for generating SQL session factory. 3, SQL session factory builder generates SQL session factory based on the definition of MyBatis configuration file. Processes that are performed for each request from the client are executed with the following flow here. 4, client request a process for the application. 5, application fetches SQL session from SQL session from 4 and 5 here. Application fetches SQL session from SQL session factory that is built by using SQL session factory builder. 6, SQL session factory generates a SQL session and return it to the application. 7, application fetches the implementation object of mapper interface from SQL session. 8 application calls mapper interface method. 9 implementation object of the mapper interface calls SQL session method and request SQL execution. 10 SQL session fetches this SQL to be executed from the mapping file and executes SQL. Transaction control. Commit and rollback for the transactions are performed by calling SQL session API from the application code. However, it is not described in this flow. When integrated with Spring transaction control functionality perform commit and rollback. As a result, the API controlling SQL session is not called directly from application class. Here you can see application is connected to SQL session factory builder. SQL session factory builder MyBatis config file and SQL session factory are inside processing to run once. SQL session factory builder is connected to MyBatis config file and SQL 2 and 3 SQL session factory build is connected to SQL session factory. And 4 client is connected to application here. Applications mapper interface SQL session and mapping files are in processing to run per request. 5 application is connected to SQL session factory. 6 application SQL session factory is connected to SQL session. 7 application interacts with connected to a SQL session, and 8 application is connected to mapper interface. 9 mapper interface is connected to SQL session, and 10 SQL session is connected to mapping file. SQL session factory builder MyBatis config file, SQL session factory and SQL session are provided by MyBatis 3. Mapper interface and mapping file implements by developer. Here you can see the relationship of MyBatis Spring components. Main components of here we are considering component structure of MyBatis. Main components of MyBatis Spring are explained here. The main components of MyBatis Spring are explained here. In MyBatis Spring, MyBatis 3 and Spring are integrated by integrating following component. Here org.mybatis.spring.SQL session factory bin component that build the SQL session SQL session factory and it stores object on Spring DI container. The standard MyBatis 3 SQL session factory is built based on the information defined in MyBatis configuration file. However, by using SQL session factory bin, SQL session factory can be built even in the absence of MyBatis configuration file. It can also be used in combination. org.mybatis.spring.mapper factory bin component that builds the singleton mapper object and stores object on Spring DI container. Mapper object generated by MyBatis 3 standard mechanism is not thread safe. Hence, it was necessary to assign an instance for each thread. Mapper object created by MyBatis Spring component can generate a thread-safe mapper object. As a result, DI can be applied to singleton components like service, etc. org.mybatis.spring.SQL session template SQL session component of singleton version that implements SQL session interface SQL session object generated by MyBatis 3 standard mechanism is not thread safe. Hence, it was necessary to assign an instance for each thread. SQL session object generated by MyBatis Spring component can generate a thread-safe SQL session object. As a result, DI can be applied to singleton components like service, etc. However, this guideline does not assume handling SQL session directly. And the flow by which the main components MyBatis Spring access the database is explained here. Processes that access database can be broadly divided into two types. Processes that are performed at the start of the application. Processes 1 to 4 mentioned here correspond to this type. Processes that are performed for each request per client. Processes 5 to 11 mentioned here correspond to this type. Processes that are performed at the start of the application are executed by the following flow. 1. SQL Session Factory bean request building SQL Session Factory for SQL Session Factory builder. 2. SQL Session Factory builder reads MyBatis configuration file for generating SQL Session Factory. 3. SQL Session Factory builder generates SQL Session Factory based on the definition of the MyBatis configuration file. SQL Session Factory thus generated is stored by the Spring DI container. 4. Mapper Factory bean generates a thread-safe SQL session template and a thread-safe mapper object, proxy object of mapper interface here. Mapper object thus generated is stored in the Spring DI container, and DI is applied for service class, etc. Mapper object provides a thread-safe implementation by using thread-safe SQL session template. Processes that are performed for each request from the client are executed by the following flow. 5. Client request a process for the application. 6. Application service calls the method of mapper object, proxy object that implements mapper interface injected by DI container. 7. Mapper object calls SQL session template method corresponding to the called method. 8. SQL session template calls the proxy enabled and thread safe session method. 9. Proxy enabled and thread safe session uses MyBatis 3 standard SQL session assigned to the transaction. When SQL session assigned to the transaction does not exist, SQL session factory method is called to fetch SQL session of the standard MyBatis 3. 10 SQL session factory returns MyBatis 3 standard SQL session. Since the returned MyBatis 3 standard SQL session is assigned to the transaction, if it is within the same transaction, same SQL session is used without creating new one. 11 MyBatis standard SQL session fetches SQL to be executed from the mapping file and execute the SQL. Transaction control, although it is not explained in the flow, the commit and rollback of transaction is performed by strings transaction control function. Here you can see SQL session bean factory, SQL session factory builder, MyBatis config file, and mapper interfaces are basically with processing to run once here. SQL session factory bean is one. Here SQL session factory bean is connected to SQL session factory builder. SQL session factory builder is connected to MyBatis config file. SQL session factory builder is connected to session factory, and 4 mapper factory bean is connected to SQL session templates. Here mapper interface, application service, JDK proxy, and mapping files are basically inside processing to run per request. SQL session is inside JDK proxy. Here 5 client is connected to application service. 6 application service is connected to mapper interface. 7 mapper interface is connected to SQL session template. 8 SQL session template is connected to JDK proxy. SQL session is inside JDK proxy, and 9 JDK proxy is connected to SQL session factory. 10 SQL session factory is connected to SQL session. 11 SQL session is connected to mapping file. And here SQL session factory bean, mapper factory bean, and SQL session template are provided by MyBatis Spring. SQL session factory builder, MyBatis config file, session factory, and SQL session are provided by MyBatis 3. Mapper interface and mapper file are provided by file implements by developer. Here you can see application architecture. MyBatis framework is used to support operation of relational database. The application architecture of the system is shown in this figure. In MyBatis framework system, the main components are SQL session factory bean and mapper scanner configurer. SQL session factory bean category relies on externally injected data sources. Data source and there are 2 attributes, config location and mapper locations. Config location specifies the location of MyBatis config file. Master location specifies the location of multiple mapper mapping files. The mapper scanner configurer relies on SQL session factory bean and automatically scans the package path based on the package location of IDAO interface specified by the base packages attribute to create mapper factory bean. Mapper factory bean category for each DAO category. The mapper factory bean category mapper factory bean category will create its specific implementation example for the IDAO interface category it correspond to, and inject it into the service layer business code. In the development of Spring Boot, replace the mobile scanner configure class with at mapper scan. Their effects are the same. When using the MyBatis frame to perform MyBatis perform database operation, the content of the red box part in the above picture needs to be realized by developers. Data source is any class example that achieve the Java x.sql.data source interface, for example awk.apache.tomcat.jdbc.pool.data source. The data source correspond to single capital single table operation, or com.dang.dd frame.rdb.sharding.jdbc.datasource.sharding data source. The data source is used in the subcapital subtable operation. IDAO is the data operation interface to realize the user's data operational logic. It's generally divided into two parts, interface and PO. The configuration files are divided into MyBatis configuration files and Kappa configuration files, mapper configuration files, and MyBatis configuration files are mainly used to design the alias of PO classes to facilitate the reference to PO classes. The mapper configuration files are used to manage SQL statement. Here you can see the mapper factory bean is connected to the IDAO IMPL, and IDAO IMPL is connected to IDAO. IDAO are in service. Here transactional and data source transactional manager are in Spring here. Here IDAO IMPLs and mapper factory beans and mapper scanner configurer base packages at mapper scan and SQL session factory bean are inside MyBatis Spring. Here mapper factory scanner configurer is connected to base packages, and mapper scan is connected to batch packages. Here you can see data sources, and here you can see config and mappers. In development, here you can see relationship between main development elements. In the development of MyBatis, the main development elements involved are DAO interface, mapper mapping files, and PO. The relations between them are as follows here. In the DAO interface category, the interface method of database operation is defined, which mainly include addition, deletion, modification, inspection, and other interface methods. The parameter of the PO category definition interface method can use the PO category to save query result. Or provide the data set for the insert update method parameter. The SQL statement for the operating database table is kept in the mapper mapping file. The map files of mobile provide select insert, update, delete XML element respectively for querying, inserting, modifying and deleting operations of the database. Each XML element is related to the method in the DAO interface category through the ID properties. Here DAO is connected to PO and DAO is connected to mapper. Here DAO is connected to mapper via namespace. Here mapper is connected to PO via result type, parameter type. Here you can see result cache. When creating a session, you can specify which executor to use. In second session level cache, first level cache, level 1 cache is enabled by default. The maximum scope of first level cache of MyBatis is inside the SQL session. In a multiple session or distributed environment, database writes operations will cause dirty data. It is recommended to set the cache level to statement. Statement level cache, secondary cache, caching executor, a level of caching is added to statement and the other logics is delegated to other executors. Implementation of cache uses the decorator pattern. Synchronized cache, then logging cache, then serialized cache, then LRU cache, then perpetual cache. Following is an introduction to the specific cache implementation classes. They are combination endos cache with different capabilities. Synchronized cache, the implementation is relatively simple and directly use the synchronized modification method. Serialized cache, logging cache, the log function decorator class is used to record the hit rate of the cache. If the debug mode is enabled, the hit rate log will be the output. Serialized cache, serialization function which serializes the value and stores it in the cache. This function is used to cache and return copy of an instance to preserve thread safety. LRU cache implementation use LRU algorithm to remove the last recently used key value. Perpetual cache is the most basic cache class. The underlying implementation is relatively simple and the HashMap is used directly. The second level cache exists across sessions and there are a great risk of reading wrong data. Moreover, most internet applications are distributed, generally do not share the state and can be expanded horizontally. However, the local cache breaks the stateless state and it is very likely to read wrong data. So it should be used with caution. Prepared statement cache, PS cache, also called PS cache, the corresponding there is a reuse executor and that this cache is also at the session level. In addition to caching at MyBatis level, you can also do caching at MySQL driver, MySQL and MySQL server. Also, here you can see client interacts with the caching executor. SQL session and configuration are inside MyBatis, and caching executor and local cache are inside SQL session. Here caching executor interacts with executor interacts with local cache, and executor interacts with database. Here caching executor interacts with configuration. Mapper namespaces are inside configuration. Caches are inside mapper namespaces, and cache interacts with memcache, OS cache, EH cache, etc. Here you can see MyBatis life cycle. It is very important to understand the various scopes and life cycle classes we using them incorrectly can cause severe concurrency problems. Note object lifecycle and dependency injection frameworks. Dependency injection frameworks can create thread-safe transactional SQL sessions and mappers and inject them directly into your bin, so you can just forget about their life cycle. You may want to have a look at MyBatis Spring or MyBatis Juice sub projects to know more about using MyBatis with DI frameworks. SQL Session Factory Builder. This class can be instantiated using this class can be instantiated, used and throw away. There is no need to keep it around once you have created your SQL Session Factory. Therefore, the best scope for instances of SQL Session Factory Builder is method scope, that is the local method variable. You can reuse the SQL Session Factory Builder to build multiple Session Factory instances. But it's still best not to keep it around to ensure that all of the XML parsing resources are freed up for more important things. SQL Session Factory. Once created, SQL Session Factory should exist for the duration of your application execution. There should be little or no reason to ever dispose of it to recreate it. It's best practice to rebuild the SQL Session Factory multiple times in an application run. Doing so should be considered a bad smell. Therefore, the best scope of SQL Session Factory is simplification scope. This can be achieved a number of ways. Simplest to use a singleton pattern or static singleton pattern. SQL Session. Each thread should have its own instance of SQL Session. Instances of SQL Sessions are not to be shared or are not thread safe. Therefore, the best scope is request or method scope. Never keep references to a SQL Session instance in a static field or even an instance field of a class. Never keep references to a SQL session in any sort of managed scope, such as HTTP session of the servlet framework. If you are using web framework of any sort, consider SQL session to follow the similar scope that of the HTTP request. In other words, upon receiving an HTTP request, you can open a SQL session. Then upon returning the scope, you can close it. Closing the session is very important. You should always ensure that it's closed within a finally block. The following is a standard pattern for ensuring that sessions are closed. Using this pattern consistently throughout your code will ensure that all database resources are properly closed. Mapper instances. Mappers are interfaces that you create to bind your mapped statement. Instances of the mapper interfaces are acquired from SQL session. As such, technically the broad scope of any mapper instance is the same as the SQL session from which they are requested. However, the best scope for the mapper instances is method scope. That is, they should be requested within the method that they are used and then be discarded. They do not need to be closed explicitly. While it's not a problem to keep around throughout as request, similar to the SQL session, you might find that managing too many resources at this level will quickly get out of hand. Keep it simple. Keep mappers in the method scope. Following example demonstrates this practice. Here, do work. Here SQL Session Factory Builder is connected to SQL Session Factory, and SQL Session Factory is connected to SQL Session. SQL Session interacts with Mapper. Now we are considering directory structure. Before we dive into the API itself, it's important to understand the best practices around directory structures. MyBatis is very flexible and you can do almost anything with your files, but as with any framework, there's a preferred way. Let's look at the typical application directory structure. Remember, these are preferences, not requirements, but others will thank you for using common directory structure. Here you can see my underscore application bin div lib the lib MyBatis *java files go here. Source, test and web are inside my underscore application. org/myapp and properties included in your XML configuration go here, are inside src. Action, data, model and service and view are inside org/myapp/ here. Data, here MyBatis artifacts go here, including mapper classes, XML configuration, XML mapping files. Here /MyBatis, here MyBatis-config.xml, blockmapper.java for example, blockmapper.xml for example are inside here, inside data. org/myapp and properties are inside test. Action, data, model, service and view are inside org/myapp. web-info is inside web, and web.xml is inside web-inf. Now we are focusing on configuration. The MyBatis configuration contains settings and properties that have a dramatic effect on how MyBatis behaves. The high-level structure of the document is as follows: configuration, properties, settings, type, aliases, type handlers, object factory, plugins, environment, transaction manager, data source, database ID provider, and mappers. Here you can see MyBatis configuration co-construction process. Configuration creation. When analyzing my SQL Session Factory before building, method was not interpreted in detail and told the pentagonist of source distribution configuration was initialized in this method. Here the XML config builder. The XML configuration file mainly used to analyze MyBatis and store the analysis results in the configuration object, and create a SQL Session Factory after getting the configuration object. The entry XPath parser. XPath parser is an XML analyzer. If the specific analysis is constructed, it will not be described. Entry environment. In order to ensure environmental configuration, this parameter specific environment medium configuration. Entry properties. Properties are the key value storage structure that inherits the hash table form, and configuration initialization through the above analysis. The configuration initial operation was in xconfig builder. Type alias registry. What is type alias? Database like MySQL, Oracle support alias, and MyBatis also provide this mechanism. The type alias in MyBatis is set to alias for the types commonly used in MyBatis, using aliases instead of specific type. What is the type purpose of type alias? The type alias is mainly used to replace complex type of multi-limited names in MyBatis, and is used to set parameter type and return result type in the mapper configuration file. Language driver registry. Language driver registry is the SQL parser in MyBatis, which stores different SQL parsers, and is the HashMap storage method along with type alias registry. Analysis MyBatis-config.xml. Parser.parse. The above will the initialization of XML config builder and initialization of configuration. Parse configuration xnode. This method is used to analyze MyBatis-config.xml to analyze various labels and store them in the configuration object. Here configuration is connected to XML builder, XML config builder configuration, XML config builder.parse, xnode :parser dot evaluate eval node method, parse configuration and configuration. Here configuration is connected via type alias registry, and here the configuration is connected to SQL via language driver registry. Here XML config builder.parse method is connected to MyBatis-config.xml. Here the xnode :parse.eval node method is connected to MyBatis-config.xml. Here parse configuration is connected to MyBatis-config.xml configuration. Here you can see configuration sources. There are three sources of configuration. MyBatis-config.xml start the file, the overall configuration and the overall components are all derived from this. Mapper.xml SQL mapping mapped statement for /result mapper all comes from this. At annotation SQL mapping and results episoding another expression. Here you can see a configuration sources. MyBatis-config.xml is connected to configuration. Mapper.xml is connected to configuration, and at annotation is connected to configuration. Here you can see a mapper registry, caches and type handler registry result maps, and type alias registry interception chain. Here new executor, new parameter handler, new result set handler, and new statement handler. These are connected to here interception chain. Here you can see overall relationship in configuration element. Configuration information comes from XMLs and nodes. Each file and node is composed of several configuration element presents a nested relationship. The overall relationship is shown in this figure. Here properties, type handler settings, environments, type aliases and mappers. Properties, settings, type aliases, and type handlers, environment, and mappers are in configuration here. Here the cache ref, SQL, parameter map, result map, select, delete, insert, and update are in mapper. At options, select, at insert, at delete, at update, at cache namespace, at cache namespace ref, at select key, at param, at result, and at result map in annotation. If for each trim, choose where set and include in script. Here you can see element bearer, whether it is XML or annotate that the weakest element of this configuration must be converted to the Java configuration attributes or objects components to carry. Corresponding relationships as follows. The global configuration config.xml carried by the configuration object attributes to here SQL mapping select, insert, or at select, etc. carried by map statement objects. 3 cache or at cache namespace carried by cache object. For the result is a mapping carried by the object of result map. Here you can see MyBatis -config.xml is connected to mapper.xml and at annotation. Here mapper.xml interact with at annotation, and mapper.xml is connected to select and update, and these are connected to select, update, etc. are connected to script here, and mapper.xml is connected to cache ref. Mapper.xml is connected to result map. Here the at annotation is connected to at select, at update. Here at annotation is connected to at select, at cache namespace, and at namespace ref. Here MyBatis -config.xml is under here configuration, with configuration, and select, update, and script at select, at update are related to mapped statements. Here cache -ref, at cache namespace, at cache namespace ref are related to cache. Here result map is related to result map here. Here here you can see a configuration file analysis. Configuration file analysis requires us to discuss separately. First, to analyze the XML analysis process. The XML configuration analysis, its bottom layer and uses DOM4J to dissolve into a node tree first, and then matches different analyzers according to the different node types. Eventually it is dissolved into a specific component. Base of the analyzer is the base builder, which contains overall configuration object. The purpose of this is that all components to be analyzed must be concentrated to a configuration at the end. Next, understand the role of each analyzer. XML config builder analyze the config.xml file and directly create a configuration object for analyzing overall configuration. XML mapper builder analyze mapper.xml files content including etc. Mapper builder assistant mapper.xml passing aid. In mapper.xml, cache is shared with the statement, SQL statement, and the allocation of shared components is achieved by this passing. XML statement builder SQL mapping analysis is select, update, insert, delete element dissolution into a mapper statement. SQL source builder SQL data source analysis, which interpolates the declared SQL to perform SQL. XML script builder SQL node script set in the analysis dynamic SQL data source. This is the class base builder, and these are the direct known subclasses: XML config builder, XML script builder, SQL source builder, XML statement builder, XML mapper builder, and mapper builder assistant. Here you can see XML file analysis process. The overall analysis process starts with XML config builder, and then gradually analyzes inward until all nodes are analyzed. We can understand the overall analysis process during the period through a mapped statement analysis process. The process description here: one XML config builder receives a config .xml input stream and then create an empty configuration object. XML config builder analyze overall configuration, and 3 XML config builder mapper elements for analysis. Designed mapper.xml files by resource URL, and XML mapper builder then analyze cache and cache result set configuration and other public configurations. XML mapper builder analyze SQL mapping, select, insert, update, delete. XML script builder analyze, generate SQL data sources including dynamic scripts. XML mapper builder build statement, mapper builder assistant set cache and add to configuration. Here you can see XML config builder and its pass, and then mapper element is connected to cache ref and result map in SQL result map SQL in XML mapper builder. and here then statement, select, update, delete, insert, and it's connected to again move to a class, and here statement is connected to XML statement builder, and here SQL source is connected to XML script builder, and here statement is connected to statement in mapper builder assistant, and here it's configuration in mapper builder assistant. Now we are considering annotation configuration analysis. The realization of the bottom of the annotation analysis is achieved by there are two ways. One is to directly specify the interface name, and the other is to specify package name and then automatically scan all the interfaces class under package. These logics are implemented by mapper registry. It received an interface class parameter and create a dynamic proxy factory. For the interface based on the parameter, then passes the internal method annotation to generate each mapper statement, and finally adds it to configuration to complete the analysis. Here you can see SqlMapConfig builder in is passed, and is a mapper element in package or package class. Here the mapper element is connected to add mappers in mapper registry. Here add mappers is connected to add mapper, and add mapper is connected to pass cache ref in mapper annotation builder here. Then it's the pass statement, then pass statement is connected to mapper statement and configuration in mapper builder assistant, and then statement. Now we are considering responsibilities of SQL session factory builder. SQL session factory builder is responsible for creating session factory SQL session factory instances. SQL session factory builder can construct an instance of SQL session factory from XML configuration file or an instance of pre-customized configuration. The configuration class contain all the content you may concern about with an instance of SQL session factory. SQL session factory builder applies the builder design pattern. It has 5 builds method that allow you to create session factory instances from different resources. Here the SQL with regarding SQL session lifecycle of the SQL session factory builder, the SQL session factory builder can be instantiated, used, and discarded. Once the SQL session factory is created, it is no longer needed. Therefore, the best scope of an instance of SQL session factory builder is the method scope, that is local method variables. You can reuse SQL session factory builder to create multiple session factory instances, but it is better not to keep it forever to ensure that all XML parsing resources can be released for more important things. Here the SQL session factory builder is connected to MyBatis-Config.xml, which is connected to configuration and which is connected to SQL session factory. Now we are here. You can see SQL session factory responsibilities. SQL session factory is responsible for creating SQL session instances. SQL session factory applies the factory design pattern, which provides a set of methods for creating SQL session instances. Method description The default open session method has no parameters. It will create a SQL session with the following characteristics. Transaction scope will be returned. Transaction scope will be turned on. That is not automatically committed. Connection objects will be obtained from data source instance configured by current environment. Transaction isolation level will use the default settings of the driver or data source. Prepared statement will not be reused, and the updates will not be processed in batches. Transaction isolation level represent the transaction isolation level, which corresponds to 5 transaction isolations levels. The executor type and enumeration type defined 3 values. Executor type dot simple. This type of executor has no special behavior. It creates a new prepared statement for execution of each statement. Executor type dot reuse. This type of execution will reuse the prepared statement. Executor type batch. This type of executor will execute all update statement in batches. If select is executed in the middle of the multiple update statement will be separated if necessary to facilitate understanding. The SQL Session Factory life cycle. SQL Session Factory should always exist in the form of a singleton during the runtime of the application. Here SQL Session Factory is connected to Open Session. Open Session is connected to SQL Session. Here none read committed, run none read uncommitted, read committed, repeatable read, and serializable is connected to transaction isolation level method. Here simple, reuse, and batch. Simple, reuse, and batch are connected to executor type. Here auto commit, transaction isolation level, executor type, and connection is connected to open session. Here you can see the methods of SQL session class. Method of the SQL session class can be roughly classified according to the following figure here. The SQL session responsibilities. The main Java interface of MyBatis is SQL session. It contains all the methods for executing statements, obtaining mappers, and managing transactions, SQL session lifecycle. SQL sessions is created by an instance of SQL Session Factory, and SQL Session Factory is created by SQL Session Factory Builder. Note, when MyBatis is used with some dependency injection frameworks such as Spring or Goose, SQL sessions will be created by the dependency injection framework, so you don't need to use SQL Session Factory Builder or SQL Session Factory. Each thread should have its own SQL session instance. The instance of SQL session is not thread safe, so it cannot be shared. So its best scope is the request or method scope. You must not put the references of SQL session instance in the static field of a class. Even the instance variables of a class. Never place a reference of a SQL session instance in any type of managed scope such as HTTP session in the servlet framework. The correct use of SQL session in the web is Every time you receive an HTTP request, you can open a SQL session, return a response and close it. Here you can see a SQL session, and here you can see identity list map, and here select insert update. Here select XSX here, and here statement and parameters are here. Then here commit rollback, and here flush statement, clear cache, close, get configuration, get mapper, and get connection. Now we are considering the internal working mechanism of SQL session. We have already understood the MyBatis encapsulate the access to the database and put session and transaction control of the database into SQL session object. So how does it work? Next we analyze the source. So here SQL session internal processing mechanisms for insert, update, delete and select are basically the same. So next I will take complete select query process. As an example, we can consider select query process. SQL session subcomponents. SQL session is the top level interface of MyBatis, which provide the methods of executing statement, obtaining mappers, and managing transaction. In fact, SQL session realizes the assurance of task by aggregating multiple subcomponents and letting each subcomponent to be responsible for its own function. So let us briefly understand core subcomponents of SQL sessions. Executor. Executor is the executor which is responsible for generating dynamic SQL and managing cache. Executor is the executor interface. There are base executor, simple executor, batch executor, reuse executor, caching executor. Statement handler. The statement handler object is responsible for setting the query parameters in the statement object, processing the result, processing the result set returned by JDBC. And processing the result sets into a list collection and return. Family members of statement handler. Statement handler is the interface. Base statement handler is an abstract class that implement statement handler with some common methods built in. Simple statement handler is responsible for processing statement. Prepared statement handler is responsible for processing prepared statement. Callable state handler is responsible for processing callable statement. Routing statement handler is responsible for processing the specific subclass and of statement handler and choose to instantiate simple statement handler, prepared statement handler, and callable statement handler according to the statement type. Parameter handler. Parameter handler is responsible for converting incoming Java objects into JDBC type objects and filling values for the dynamic SQL of prepared statement. Parameter handler has only one concrete implementation class, namely default parameter handler. Result set handler. Result set handler is responsible for two things: process the result set generated after the statement is executed, and generate the result set. Processing the output parameters after the execution of the stored procedure. Result set handler has only one concrete implementation class, namely the default result set handler. Type handler. Type handler is responsible for converting between Java objects types and the JDBC types. SQL session and mapper here, and here you can see SQL session interacts with executor interacts with statement handler interacts with the parameter handler, and parameter handler is connected to type handler and restatement. Here statements are connected to result set, and result set is connected to type handler, and result set handler. Type handler is connected to the result set handler here. And here the result set SQL session is connected to executor is connected to statement handler is connected to parameter handler, and here statement, and parameter handler is connected to statement, and type handler is connected to statement. Prepare statement, simple statement, and callable statements are inside statement. Statement is connected to result set is connected to type handler, and type handler is connected to result set handler. Here result set is connected to result set handler. Result set handler is connected to statement handler is connected to execute is connected to SQL session. And here you can see SQL source and result maps are inside the mapper mapped statement mapper. Map statement mapper is inside configuration MyBatis, and here you see params object, row bounds, and bound SQL. And here this SQL session executor, statement handler, parameter handler, type handler, result set, and configuration MyBatis param object, row bounds, bound SQL are inside MyBatis, and here statement and result set inside JDBC, and JDBC interacts with the database. Here here MySQL, Oracle, H2, PostgreSQL, DB2, etc. Here you can see a SQL session. As its name suggests, SQL session corresponds to a database session. Since database session is not permanent, the lifecycle of a session should not be permanent. On contrary, you need to create it every time you access the database. Of course, it does not mean that you can execute. You can only execute SQL once in SQL session. You can execute multiple times when the SQL session needs to be recreated once it is closed. Let's look at how to get SQL session first. For SQL session, factory builder reads the configuration file of MyBatis, and then builds a default SQL session factory. We then when we get the SQL session factory, we can get SQL session object through the SQL session factory. Through the above steps, we have obtained a SQL session object. Then you can and here you can see actor is here, and SQL session factory builder, default SQL session factory, and default SQL session. Is one build actor is connected to SQL session factory builder via build. Here SQL session factory is connected to itself, then via build configuration, and SQL session factory is the builder is connected to default SQL session factory, and then return default SQL session factory to SQL session factory builder. Then it's connected to here. The SQL session factory builder is connected to return default SQL session factory to the actor. Then it's actor here. The open actor is connected to default SQL session factory via open session. Then default session factory is connected to itself via open session from data source. Then the default session factory is connected to default SQL session factory is connected to default SQL session here. Then it return default SQL session. Then it return default SQL session factory to actor. Here you can see a SQL session creation process. SQL session is connected to SQL session factory via open session. SQL session factory is connected to transaction factory via new transaction. Transaction factory is connected to transaction via new. Here transaction is connected to default source connection and transaction isolation level. You can see here executor. Execute transaction, default source connection, and transaction isolation level is in one group, and with this group, and data default SQL session is another group, and this is connected to SQL session. Here you can see SQL session implementation process. Here via select list connected to SQL session. To SQL session is connected to configuration via get map statement. Configuration is connected to map statement via ID. Map statement is connected to SQL session. SQL session is connected to executor via query. Execute is connected to statement handler via new statement handler and prepare. Statement handler is connected to connection via prepare statement. Statement handler statement handler interacts with connection. Statement handler execute is connected to statement handler via parameterize, and statement at 9 statement handler is connected to parameter handler via set parameters. Then executor is connected to statement handler via query. Here statement handler is connected to statement via execute. Statement is connected to statement in IMPL via execute. Here 12. Here in the 8-step connection is connected to connection in IMPL via prepare statement here. Here connection interacts with connection IMPL. Here statement interacts with statement IMPL, and Here statement handler interacts with statement, and statement handler is connected to result set handler. Inside result set handler you can see handle result set, handle cursor result set, handle output parameters. Result set handler interacts with type handler, set parameter, get result. Result set handler is connected to type handler via get results. Here parameter handler is connected to type handler via set parameter, and parameter handler is connected to statement. Connection IMPL interacts with DB. Here statement IMPL, the implementation interacts with DB. Here SQL session, configuration, connection, executor, map statement, and statements are in map statement level. Here statement handler, result set handler, parameter handler, type handler are in statement level, and here connection IMPL and statement IMPL in JDBC level, and here DB is in DB level. Here basically connection, executor, map statement, and statement are in map statement level here basically. Here you can see the executor. The relationship between executor and SQL session is like mayor and secretary. SQL session is just a facade, and real thing is executor. SQL sessions operations on database are all done through executor. Like SQL session, executor is created dynamically. It can be seen that if the cache is not enabled, the created executor is only one of three basic types. Batch executor is especially used to execute batch SQL operations. Reuse executor will reuse statement to execute SQL operations. Simple executor simply executes SQL without anything special. When the cache is enabled, it is enabled by default, and there is no reason to disable it. The caching executor is created that takes the previously created executor as it's only one parameter. Caching executor searches the cache before querying the database. If it is not found, it calls the delegate, that is executor object passed in during construction to query the database and store the query result in the cache. Executor objects can be interpreted by plugins. If the plugin for the executor type is defined, the resulting executor object is a proxy object inserted by the plugin. Next, we look at the execution process of SQL. Above we got the mapper proxy. Each mapper proxy corresponding to DAO interfaces. So how do we use mapper proxy when we use it? The mapper proxy, we know that access to the method of proxies object will be implemented in the invoke of the proxy. The mapper method, like a distributor, we choose to like distributor, he chooses different SQL session methods to execute according to the parameters and return value types. In this way the mapper object and SQL sessions are truly associated. Now that we are back to SQL session, as we mentioned earlier, SQL session is just a facade, and it is the executor that really plays the role. we access the SQL session method will eventually fall to the corresponding method of the executor. Executor is divided into two categories. One is cache executor and the other is ordinary execution. The creation of the executor has been introduced before, so let's look at the crude method of a SQL session. Cache executor has the important attribute delegate, which stores a certain type of column common executor. The value is passed in when framing, when executing the database update operation. It's directly called the update method for the delegate, and executing query method if it first tries to get the value from the cache. Ordinary executor, there are three types. They all are inherited from the base executor. Batch executor is specially used to execute batch SQL operations. Reuse executor will use statement to execute SQL operations, and simple executor simply execute SQL without anything special. Then through layer by layer calls, we will finally come to the do query method. Here let's find an executor to see implementation of do query method. I choose here simple executor here. There are three built-in executor types in MyBatis. The default is simple. In this mode, it creates a new prepared statement for execution of each statement and submit a single SQL statement, while the batch mode reuses the prepared statement and executes all the batches. Update statement, obviously the batch performance will be better, but the batch mode also has its own problems. For example, and in the insert operation before the transaction is committed, there is no way to obtain self-incrementing ID, which does not meet the business requirement in certain types of situations. Here you can see actor, mapped proxy, mapped method, default SQL session, simple executor, prepared statement, and result set here. See here actor is connected to mapped proxy via invoke. Mapped proxy is connected to mapped method via execute method. Here map method is connected to itself via crude. Here map method is connected to default SQL session. Default SQL session is connected to simple executor via query method. Here simple executor is connected to itself via query from the database, and simple executor is connected to itself via do query. And here simple executor is connected to prepared statement via query. Prepared statement is connected to itself via execute, and here prepared statement is connected to handle result set. Prepared statement is connected to result set handler via handle result set method, and it returns to prepared statement. The result set handler then return to the prepared statement. It's returned to the simple execute. It's returned to the default session, and it returned to the actor. As an example, we can consider package class class configuration. This is in the package org.apache.ibatis.session. Here we are considering building SQL session factory from XML. MyBatis includes a utility class called resources that contains a number of methods that make it simpler to load resources from the class path and other locations. This is the interface SQL Session Factory creates an SQL session out of a connection or a data source. This is in the package org.apache.ibatis.session. Every MyBatis application centers around an instance of a SQL Session Factory. A SQL Session Factory instance can be acquired by using SQL Session Factory Builder. SQL Session Factory Builder can build a SQL Session Factory instance from an XML configuration file or from a custom prepared instance of a configuration class. Building a SQL Session Factory instance from an XML file is very simple. It is recommended that you can use class path resource for use a class path resource for this configuration, but you could use any input stream instance, including one created from a literal file path or a file : / URL. MyBatis includes a utility class called resources that contains a number of methods that make it simpler to load resources from a class path and other locations. Here is a simple example. The configuration XML file contains settings for the core of the MyBatis system, including a data source for acquiring database connection instances, as well as a transaction manager for determining how transaction could be scoped and controlled. The full details of XML configuration file can be found in the documentation, but here is a simple example. While there is a lot more to XML configuration file, this example points out the most critical parts. Notice the XML header required to validate XML document. The body of the environment element contains the environment configuration for transaction management and connection pooling. The mappers element contains a list of mappers, the XML files, and or annotated Java interface classes that contain SQL code and mapping definitions. Now we are considering building a SQL session factory without XML. If you prefer to directly build the configuration from the Java rather than XML, or create your own configuration builder, MyBatis provide a complete configuration class that provide all the same configuration options as the XML file. Here SQL session factory creates an SQL session out of a connection or a data source. Notice in this case the configuration is adding a mapper class. Mapper classes are Java classes that contain SQL mapping annotations that avoid the need for XML mapping. However, due to some limitations of Java annotations, the complexity of some MyBatis mappings, XML mapping is still required for most advanced mapping, for example, nested join mapping. For this reason, MyBatis will automatically look for and load a peer XML file if exists. In this case, SqlMapConfig.xml would be loaded based on the class path and the name of the of blogmapper.class. Now we are considering acquiring a SQL session from a SQL session factory. For example, here the interface SQL session, the primary Java interface for working with MyBatis. Through this interface, you can execute command, get mappers, and manage transactions. This is in the package org.apache.mybatis.session. Now you have a SQL session factory here. The name, as the name suggests, you can acquire an instance of SQL session. The SQL session contains absolutely every method needed to execute SQL commands against the database. You can execute mapped SQL statements directly against SQL session instance. For example, here, while this approach works and is familiar to users of the previous versions of MyBatis, here is now a cleaner approach. Using an interface, for example, blogmapper.class that properly describe the parameter and return value for a given statement, you can now execute cleaner and more type-safe code without error-prone string literals and casting. For example, here, now we are considering properties in configuration XML. For example, here, these are externalizable, substitutable properties that can be configured in a typical Java properties file instance or passed through sub-element of properties element. For example, here the properties can then be used throughout the configuration files to substitute values that need to be dynamically configured. For example, here the username and password in this example will be replaced by the values set in the properties element. The driver and URL properties would be replaced with various content from the config.properties file. This provides a lot of options for configuration. Properties can also pass into SQL session builder dot build methods. For example, here if a property exists in more than one of these places, MyBatis loads them in the following order. Properties specified in the body of the properties element are read first. Properties loaded from the class path resource, so URL attributes of the properties element are read second and override any duplicate properties already specified. Properties passed as a method parameter are read last and override any duplicate properties that may have been loaded from properties body and the resource URL attributes. Thus, the highest priority properties are those passed in as a method parameter, followed by resource URL attributes, and finally the properties specified in the body of the properties element. Or since MyBatis 3.4.2, you can specify default value placeholder as follows. This switch is disabled by default. If you specify default value placeholder, you should be able to you should able to use this feature. Here, if the username property is not present, username become ut user. Now we are considering settings. An example of settings element fully configured is as follows. Here the settings name cache enabled globally enables or disabled any cache configured in any mapper under this configuration. Valid values are true and false and default true. Here the lazy loading enabled globally enables and disable lazy loading. When enabled, all relations will be lazy loaded, and this value can be superseded for a specific relation by using fetch type attribute in it. Valid values are true or false. Default is false. Aggressive lazy loading, when enabled, any method any method call will load all lazy parameters of the object. Otherwise, each property is loaded on demand. Valid values are true or false, and false default values is true, and default value is false and true in 3.4.1. Multiple result sets enabled, allow or disallow multiple result sets to be returned from a single statement. Compatible driver required. The values are true, valid values are true or false, and default is true. Use column label, uses a column label instead of the column name. Different drivers behave differently in this respect. Refer to the driver documentation or test out both to determine how your driver behaves. The valid values are true or false and default to true. Use generated keys, allow JDBC support for generated keys. A compatible driver is required. This setting forces generated keys to be used if set to true, as some drivers deny compatibility but still work. For example, Derby, where valid values are true or false and default is false. Auto mapping behavior, specify if and how MyBatis should automatically map columns or fields columns to fields or properties. None disables auto mapping, and partial will only auto map results with no nested result mapping defined inside. Full will auto map results mapping to any complexity containing nested or otherwise. Valid values are none, partial and full. Default is partial. Auto mapping unknown column behavior, specify the behavior when detects an unknown column or unknown property type of automatic mapping target. None do nothing. Warning output warning log. The log level of org.apache.ibatis.session.auto mapping unknown column behavior must set to warn, and failing fall mapping through SQL session exception. None valid values are none, warning, and failing. Default is none. Default executor type, configure the default executor. Simple executor does nothing special. Executor reuses prepared statement. Batch executor reuses statement. Batch updates. Simple default values for simple reuse batch, default to simple. Default statement timeout sets the number of seconds the driver will wait for a response from database. Valid values are any positive integer. Default is not set. Default fetch size sets the driver a hint as to control fetching size for the return results. This parameter value can be override by the query string. Valid values are any positive integer, and default to set not set is null. Safe row bounds enabled, allow using round bounds on nested elements. If allow, set the false. Default valid values are true or false and default to false. Safe result handler enabled. Allow using result handler on nested statement. If allow, set the false. Default default value is true. Map underscore to camel case. Enable automatic mapping from classic database columns names underscore column to camel case classic Java property names a column. Default valid values are true or false. Default to false. Local cache scope. MyBatis uses local cache to prevent circular references and speed up repeated nested queries. By default session, all queries executed during a session are cached. If a local cache scope equals statement, local session will be used just for statement execution. No data will be shared between two different calls to the same SQL session. Valid values are session or statement. Default to session. JDBC type for null. Specifies JDBC type for null values when no specific JDBC type was provided for the parameter. Some drivers require specifying the column JDBC type, but others work with generic values like null, varchar, and other. JDBC type valid values are JDBC type enumeration. Most common null, varchar, and other. Default to other. Lazy load trigger methods specified which object methods trigger lazy load. Valid values are a method name list separated by commas. Default is equal, clone, hash code, and two string. Default scripting language. Specify the language used by default dynamic SQL generation. A type alias or fully qualified class names are valued values. Default to org.apache.ibatis.scripting.xml tags.xml language driver. Default enum type handler. Specify the type handler used by the default for enum since 3.4.5. Valid values are type alias or fully qualified class name. Default to org.apache.ibatis.type.enum type handler. Call setters on nulls. Specify if setters so maps put method will be called when a retrieved value is null. It is useful when you rely on map.keyset method or null value initialization. Note primitives such as int, boolean, etc. will not be set to null. Valid values will be true or false. Default to false. Return instance for empty row. MyBatis by default return null when all columns of a return now are null. When this settings is enabled, MyBatis return an empty instance instead. Note that this is also applied to nested results, that is collection and association, since 3.4.2. True or false and default to false. Log prefix specified the prefix string that MyBatis will add to the logger names. Valid values are any string and default to not set. Log IMPL and specify which when logging implementation MyBatis should use. If this setting is not present, logging implementation will be auto discovered. Valid values are SL F4J or log4j deprecated since 3.5.9, log4j2 or jdk underscore logging or commands underscore logging or std out underscore logging or no logging. Default is not set. Proxy factory, specify the proxy tool that MyBatis will use for creating lazy loading capable objects. Valid values are cglib deprecated since 3.5.10 and Java Assist and default to Java Assist MyBatis 3.3 or above. VFS IMPL specified VSF implementation. Fully qualified valid values is fully qualified class names of the custom VSF implementation separated by commas, default to not set. Use actual param name, allow referencing element statement parameters by their actual names declared in the method signature. To use this feature, your project must be compared with Java 8 with dash parameter option since 3.4.1. Valid values are true or false and default to true. Configuration factory, they specified the class that provide an instance of configuration. The return configuration instance is used to load lazy properties of decentralized object. This class must have a method with the signature static configuration get configurer method since 3.2.3. Type valid values are a type, alias or fully qualified class name. Default is not set. And there are other settings like shrink white space in SQL, default SQL provider type, nullable on for each, arg name based constructor auto mapping. Now we are considering type aliases. For example, here the annotation interface alias, the annotation that specify alias name. This is in the package org.apache.ibatis.type. A type alias is simply a shorter name for the Java type. It's only relevant to the XML configuration and simply exists to reduce the redundant typing of fully qualified class names. For example, here with this configuration, blog can now be used anywhere that domain.blog.blog could be. You can also specify a package where MyBatis will search for beans. For example, here each bean found in domain.blog, if no annotation is found, will be registered as an alias using uncapitalized non-qualified class name of the bean, that is domain.blog.author will be registered as author in simple letters. If the alias annotation is found, its value will be used as an alias, for example below. Now we are considering type handlers. For example, here the package the class base type handler T, the base type handler for references a generic type. This is in the package org.apache.ibatis.type. Whenever MyBatis sets a parameter on a prepared statement, or retrieve a value from a result set, a type handler is used to retrieve a value in a means appropriate to Java type. For example, there are default type handlers, for example boolean type handler for java.lang.boolean or boolean, and JDBC type any compatible boolean, for example. You can override the type handlers or create your own to deal with unsupported or non-standard types. To do implement the interface org.apache.ibatis.type handler, or extend the convenience class org.apache.ibatis.type.base type handler, and optionally map it to the JDBC type, for example here. Using such a type handler would override the existing type handler for Java string properties and varchar parameter and results. Note that MyBatis does not support introspect upon database metadata to determine the type, so you must specify that it's a varchar field in the parameter and the result mapping to hook in the correct type handler. This is due to the fact that MyBatis is unaware of the type until statement is executed. MyBatis will know the Java type that you want to handle with this type handler by introspecting its generic type, but you can override this behavior by two means: adding Java type attributes to the type handler element, for example Java type equal string, or adding @map types annotation to a type handler class, specifying the list of Java types to associate with. This annotation will be ignored in Java type attribute has also been specified. The associated JDBC type can be specified by two means: adding JDBC type attributes to the type handler element, for example JDBC type equal varchar, or adding mapped JDBC types annotation to your handler class, specifying the list of JDBC types to associate with. This annotation will be ignored if the JDBC type attribute is also been specified. When deciding which type handler to use in a result map, Java type is known from the result type, but the JDBC type is unknown. MyBatis therefore uses combination of Java type equal the Java type, Java type equal JDBC type equal null to choose the type handler. This means that using map JDBC types annotation restricts the scope of a type handler and make it unavailable for use in result maps unless explicitly set. To make the type handler available for use in the result map set, include null JDBC type equal true on at map JDBC types annotation. Since MyBatis 3.4.0, however, a single type handler is registered to handle Java type. It will be used by default in result maps using this Java type. For example, even without include null JDBC equal true, include null JDBC type equal true. MyBatis-config.xml. Now we are considering handling enums. That's just as easy an odd enum. Add enum ordinal type handler to the type handlers in your config file, and now each rounding mode will be mapped to an integer using its ordinal value. Enum ordinal type handler e extend enum e. This in the package org.apache.ibatis.type. If you want to map an enum, you will need to use either enum type handler or enum ordinal type handler. For example, let's say that we need to store the rounding mode that shows that should be used with some number if it needs to be rounded. By default, the MyBatis uses enum type handler to convert enum values to their names. Note, enum type handler is special in sense that unlike other type handlers that does not handle just one specific class, but any class that extend enum. However, we may not want to store names. Our DBA may insist an integer code instead. That just as easy as add enum ordinal type handler to the type handlers in your config file, and now each rounding mode will be mapped to an integer using ordinal value. But what if you want to map the same enum to string in one place and to integer in another? The automapper will automatically use ordinal type handler, and so if we want to go back to using plain old ordinary enum type handler, we have to tell it by explicitly setting the type handler to use for those SQL statement. Mapper files aren't converted until the next here we are skipping mapper files, and this is a segment of the code. This forces to use result map instead of result type in our select statement. That code is omitted here. The MyBatis Config.xml. Each time, now we are considering object factory. For example, here default object the class default object factory, which is in org.apache.ibatis.reflection.factory. Each time MyBatis creates a new instance of a result object, it uses object factory instance to do so. The default object factory does little more than instantiate the target class with the default constructor or a parameterized constructor if a parameter mappings exist. If you want to override the default behavior of object factory, you can create your own. The object factory interface is very simple. It contains two create methods, one to deal with the default constructor and the other to deal with the parameterized constructors. Finally, set properties method can be used to configure the object factory. Properties defined within your body of the object factory element will be passed to the set properties method. After initialization of your object factory instance. MyBatis-config.xml. Now we are considering plugins. Simply implement the interceptor interface, being sure to specify the signatures you want to intercept. The class, the interface interceptor, which is in org.apache.ibatis.plugin. MyBatis allows you to intercept calls to a certain points within execution of a mapped statement. By default, MyBatis allows plugins to intercept method calls of executor, update query, flash statement, commit, rollback, get transaction close is closed, parameter handler, get parameter object, set parameters, result set handler, handle result set, handle output parameter, statement handler, prepare parameterized batch update query. The details of these class methods can be discovered by looking at the full method signature of each. The source code, which is available with MyBatis, each MyBatis release, you should understand the behavior of method you are overriding. Assuming you are doing something more than just monitoring calls, if you attempt to modify or override the behavior of a given method, you are likely to break the core of MyBatis. These are low-level classes and methods, so use plugins with caution. Using plugins is pretty simple. Given the power they provide, simply implement the interceptor interface, being sure to specify signatures you want to intercept. The plugin above calls the update method on the executor instance, which is an internal object responsible for low-level execution of mapped statement. Not overriding configuration class. In addition to modify the core MyBatis behavior with plugins, you can also override the configuration class entirely. Simply extend it and override any method inside the inside and pass it to the core. Pass into the call to SQL session factory builder.build myconfig method. Again, though, this could have a severe impact on behavior of MyBatis, so use caution. MyBatis-config.xml. Implement pre-processing if needed. Implement post-processing if needed. Now we are considering environments. The environments element define how the environment is configured. MyBatis can be configured with multiple environments. This helps you to apply your SQL maps to multiple databases for any number of reasons. For example, you might have a different configuration for your development, test and production environment, or you may have multiple production databases that share the same schema and you would like to use the same SQL maps for both. There are many use cases. One important thing to remember though, while you can configure multiple environments, you can only use one per SQL session factory instance. If you want to connect to two databases, you need to create two instances of SQL session factory, one for each, and for three databases you need three instances, and so on. It's really easy to remember. One SQL session factory instance per database. To specify which environment to build, you simply pass it to the SQL session factory builder as an optional parameter. These two signatures that accepts the environments are here. If the environment is omitted, then the default environment is loaded as follows. The environment element defines how the environment is configured. Notice the key sections here. The default environment ID, for example, default equal development. The environment ID for each environment defined, ID, for example, ID equal development. The transaction manager configuration, for example, type equal JDBC. The data source configuration, for example, type equal pooled. The default environment and the environment IDs are self-explanatory. Name them whatever you like. Just make sure the default matches one of them. With transaction manager, there are two transaction manager types, that is type JDBC and or managed that are included with MyBatis JDBC. This configuration simply makes use of the JDBC commit and rollback facilities directly. It relies on the connection retrieved from the data source to manage the scope of the transaction. By default, it enables auto commit when choosing the connection for a compatibility with some drivers. However, for some drivers, enabling auto commit is not only unnecessary but also an expensive operation. So since version 3.5.10, you can skip this step by setting skip set auto commit on clause properties to true. Other type is managed. This configuration simply does almost nothing. It never commit or roll back the connection. Instead, it lets the container manage the full life cycle of the transaction. That is, for example, JEE application server context. By default, it does not close the connection. However, some containers don't expect this, and thus if you need to stop it from closing the connection, set close connection property to false. If you are planning to use MyBatis with Spring, there is no need to configure any transaction manager, because the Spring module will set its own overriding any previous set configuration. Data source, the data source element configure the data source of a JDBC connection objects using standard JDBC data source interface. Most MyBatis applications will configure the data source as in the example. However, it's not required. Realize though that's to facilitate lazy loading, and this data source is required. There are three built-in data source types: unpooled, pooled, and JNDI. Unpooled this implementation of a database simply open and closes connection each time it is requested. While it's a bit slower, that is a good choice for simple applications that do not require the performance of immediately available connection. Different databases are also different in this performance area. So for some, it may less important to pool. This configuration be ideal. Pooled, this implementation of data source pools JDBC connection objects to avoid the initial connection and authentication time required to create new connection instance. This is a popular approach for concurrent web application to achieve the fast response. JNDI option is this implementation of data source is intended to use for the containers such as EGP or application server that may configure the data source centrally or externally and place the reference to it in JNDI context. Now we are considering database ID provider. Given that usually that string is too long and that different versions of the same product may return different values, you may want to convert this to a shorter one by adding properties like here follows. The database ID provide the interface database ID provider, which is in the package okta.apache.ibatis.mapping, should return an old ID to identify the type of this database. That ID can be used later on the build later on to the build different queries for each database type. This mechanism enables supporting multiple vendors and versions. MyBatis is able to execute different statements depending on your database vendor. The multi-DB vendor support is based on the mapped statement database ID attribute. MyBatis will load statements with no database ID attribute or with database ID that matches the current one. In case some statement is found with or without the database ID, the latter will be discarded. To enable the multi-vendor support, add the database ID provider to MyBatis Config.xml file as follows here. DB vendor implementation, DB underscore vendor implementation database provider sets the database ID string returned by database metadata hash get database product name method. Given that usually that string is too long and there's different versions of the same product may return the different values, you may want to convert it to a shorter one by adding properties like as follows. When properties are provided, the DB underscore vendor database provider will search the property value corresponding to the first key found in the return database product name or null if there is no matching property. In this case, get database product name method returns Oracle data direct. The database ID will set to Oracle. You can build your own database ID provider by implementing the interface org.apache.ibatis.mapping.database ID provider and registering in it in the MyBatis-config.xml. Since the 3.5.2 changed to default method and NOP. Now we are considering mappers, for example here. Now that the behavior of MyBatis is configured with the previous configuration element, we are ready to define our mapped SQL statements. But first we need to tell MyBatis where to find them. Java doesn't really provide any good means to auto discovery of this regard. So the best way to do is to simply tell MyBatis where to find the mapping files. You can use class path, relative resource references, fully qualified URL references, including file / URL, class names or package names, for example. Here using class path relative resources, you can use using URL fully qualified path, URL mapper interface classes, register all interfaces in a package as mappers. These statements simply tell MyBatis where to go where to go from here. The rest of the details are in each of the SQL mapping files, and that's exactly what the SQL mapping files. Using class path relative resources. Now we are considering SQL session builder in SQL sessions in Java API. Here is an example of building SQL session factory from an MyBatis-config.xml file. The SQL session factory builder builds SQL session instances using the package org.apache.mybatis.session. The SQL session factory builder has 5 build methods, each which allow you to build a SQL session factory from different sources. The first 4 methods are the most common, and as they take input stream instance that refers to an XML document, or more specifically the MyBatis Config.xml file discussed here. The optional parameters are environment properties for the other build methods, environments and properties. Environment determines which environment to load, including the data source and transaction manager. For example, if we put environment here, we can consider this one, or if we take the default one. The first 4, if you call the build method that takes the environment parameter, then the MyBatis will use the configuration for that environment. Of course, if you specify invalid environment, you could receive an error. If you call one of the build method that does not take the environment parameter, then the default environment is used, which is specified as the default equal development in the example here. If you call here if you called a method that takes a properties instance, then the MyBatis will load those properties and make them available to your configuration. Those properties can be used in the place of most values in the configuration using syntax $, open curly brace, prop name, close curly brace. Recall that properties can also be referenced from the MyBatis-config.xml file or specified directly within it. Therefore, it is important to understand the priority. We mentioned it before also, but here we are telling it again. If the property exists in more than one of these places, MyBatis load them in the following order. Properties specified in the body of the properties element are read first. Properties loaded from the class path, resource, or URI attributes of the properties elements are read second, and override and duplicate properties already specified. Properties passed as a method parameter are read first, read last, and the override any duplicate properties that may have been loaded from the properties body and the resource URL attributes. Thus, the highest priority properties are those passed in as a method parameter, followed by resource or URL attributes, and finally the properties specified in the body of the properties element. To summarize, the first 4 methods are largely the same. Here build method, but with the override, they allow you to optionally specify the environment or properties in build methods. Here is an example of building SQL session factory from an MyBatis-config.xml. Notice that we are making use of the resources utility class, which lives in the org.apache.ibatis.io package. The resources class, as its name implies, helps you load resources from the class path, file system, or even a web URL. A quick look at the class source code and inspection through your ID will reveal It's fairly obvious set of useful methods. Here's a quick list. The final build method takes an instance of the configuration. The configuration class contains everything you could possibly need to know about SQL Session Factory. The Session Factory instance. The configuration class is useful for introspecting on the configuration, including finding and manipulating SQL maps. Not recommended once an application is accepting requests. The configuration class has every configuration switch that you have learned about already and only exposed as a Java API. Here's a simple example of how to manually a configuration instance and pass it to a build method to create a SQL Session Factory. Now you have SQL Session Factory that can be used to create SQL Session instances. Now we are considering SQL Session Factory. SQL Session Factory has 6 methods that are used to create SQL Session instances. In general, the decision you will be making when selecting one of these methods are transaction. Do you want to use transaction scope for the session, or use auto commit? Usually means no transaction with most databases and no JDBC drivers. Connection, do you want MyBatis to acquire a connection from the configured data source for you, or do you want to provide your own? Execution, do you want MyBatis to reuse prepared statement and or batch updates including inserts and deletes? The set of ordered open session method signatures allow you to choose any combination of these options that make sense. The default session method or default open session method that makes no parameters will create a SQL session with the following characteristics. Transaction scope will stand, that is not auto commit. Connection object will be acquired from the data source instance configured by the active environment. The transaction isolation level will be the default used by the driver or data source. No prepared statement will be reused or no updates will be patched. Most of the methods are pretty self-explanatory. To enable auto commit, pass a value pass a value of true to the optional auto commit parameter to provide your own connection past an instance of connection on the connection parameter. Note that there is no override to set both the connection and auto commit, because MyBatis will use whatever settings that provider connection object is currently using. MyBatis uses a Java enumeration wrapper for transaction isolation levels called transaction isolation level, but otherwise they worked as expected and have the 5 level supported by JDBC. None, real, uncommitted, real, committed, repeatable, read, serializable. The one parameter that might be new to you is executor type. This enumeration defines 3 values. Executor type dot simple. This type of executor does nothing special. It creates a new prepared statement for each execution of a statement. Executor type reuse. This type of executor will reuse prepared statement. Executor type batch. This executor will batch all update statement and demarcate the necessary if selects are executed between them to ensure an easy to understand behavior. There's one more method on SQL Session Factory that we didn't mention, and that is get configuration method. This method will return an instance of configuration that you can use to introspect upon the MyBatis configuration at runtime. Note, if you have used a previous version of MyBatis, you will recall the session that sessions, transaction and batches all nothing separate. This is no longer the case. There are 3 neatly contained within the scope of a session. You need to deal with transaction or batches separated to get full benefit of them. This interface SQL Session Factory creates an SQL session out of connection or data source. This is in the package octo.apache.ibatis.session. Now we are considering ensuring that SQL session is closed in SQL session. The best way to ensure this is to use the following unit of work pattern. SQL session, interface SQL session. This is in the package octo.apache.ibatis.session, the primary Java interface for working with MyBatis. Through this interface, you can execute command, get mappers, and manage transactions. Void close method. The most important thing you need to ensure is to close any session that you open. The best way to ensure this is to use the following unit of work pattern here. Just like SQL Session Factory, you can get the instance of configuration that the SQL session is used by calling get configuration method. Configuration, get configuration. Here the following 3 lines are pseudocode for doing some work. Here the as an exception example, we can consider invalid configuration exception. This is in the package org.mybatis.generator.exception. As an exception example 2, we can consider SQL session exception. This can occur in settings auto mapping unknown column behavior. If there's a fail mapping, it can throw SQL session exception. Now we are focusing on mapper annotations. Since the very beginning, MyBatis has been an XML driven framework. The configuration is XML based and the mapped statements are defined in XML. With MyBatis 3, there are new options available. MyBatis 3 builds on top of a comprehensive and powerful Java-based configuration API. This configuration API is the foundation for the XML-based MyBatis configuration, as well as the new annotation-based configuration. Annotations offer a simple way to implement simple mapped statements without introducing a lot of overhead. As an example, we can consider this. This example shows using select key annotation to retrieve value from a sequence before an insert. Annotation insert, the annotation that specify an SQL for inserting records. Annotation select key, the annotation that specify an SQL for retrieving key value. Now we are considering mapper annotations in SQL session. Here the annotation interface cache namespace. This the annotation that is specified to use caching on namespace, for example mapper interface. This is in the package org.apache.ibatis.annotations. The target is a class and XML equivalent is cache. Configures the cache for given namespace, that is class, attributes, implementation, eviction, flush interval, size, read write, blocking and properties. Now we are considering mapper annotation examples. This example shows using at select key annotation to retrieve a value from a sequence before insert. The annotation interface select key, the annotation that specify an SQL for retrieving key value. Is in the package org.apache.ibatis.annotations. Here this is an example, shows this at select key annotation to retrieve an identity value after an insert. This example shows using @flush annotation to call SQL session at #flush statements. The annotation interface flush, the mark annotation that invoke a flush statement via mapper interface. This example shows how to name result map specifying ID attributes of @results annotation. The annotation interface results, the annotation that be grouping mapping definition for property. This in the package org.apache.ibatis.annotations. Now here this example shows solo parameter using select provider annotation. The annotation interface, the select provider, and the annotation that is specify a method that provide and SQL for retrieving record. This is in the package org.apache.ibatis.annotations. This example shows multiple parameters using SQL provider annotations. If not use @param, you should be define the same arguments with mapper method. If use @param, you can define the only argument to be used. This example shows usage that share SQL provider class to all mapper methods using global configuration available since 3.5.6. Here they specify an SQL provider class for sharing on all mapper methods. Here can omit type value attributes on SQL provider annotations. If omitted, the MyBatis will apply the class that is specified in the default SQL provider type. Here the annotation type, annotation interface select provider, the annotation that is specify a method that provides us an SQL for retrieving records. Annotation interface insert provider, and the annotation that is specify a method that provides an SQL for inserting records. This is retrieving records. The annotation interface update provider, that and the annotation that is specify a method that provide an SQL for updating records. The annotation interface delete provider, the annotation that is specify a method that provide an SQL for deleting records. Here the same with at select provider template file path provider.class. Here the same with at insert provider template file path provider.class. Here the same with at update provider template file path provider class. Here the at delete provider, same with at delete provider template file path provider class. This example shows the usage of default implementation of provider method resolver available since MyBatis 3.5.1 or later. Interface provider method resolver, the interface that resolved an SQL provider method via an SQL provider class. This is in the package org.apache.mybatis.builder.annotation. Implements the provider method resolver on your provider class. The default implementation in default implementation, it will resolve the method that the method name mismatch with the mapper method. In this example shows usage of database ID attribute on annotations. Use this statement if database ID provide Oracle. Use this statement if database ID provide Postgres. Use this statement if the database provider not configured or not matches database ID. As an error example, we can consider this: cannot use both ampersand at and ampersand many annotations in the same ampersand result. This error occurred in MyBatis 3.2.6. Now we are focusing on SqlMapConfig.xml as a global configuration file of MyBatis. Configures the running environment of MyBatis and other information. Here you can see the hierarchical structure of MyBatis configuration file. Basically, we need to master the configuration of nine top level elements, including tags orange, red, because it involves plugin unit and dynamic SQL plugin in configuration can be applied to pagination and function enhancement. Dynamic SQL such as if tag, where tag, for each tag is primarily understood to be applied to SQL statement splicing. Properties. These are externalizable substitutable properties that can be configured in a typical Java properties file instance or passed in through sub-elements of the properties element. Settings. These are externally important tweaks that modify the way that MyBatis behaves at runtime. Type aliases. A type alias is simply a shorter name for a Java type. It's only relevant to the XML configuration and simply exists to reduce redundant type of fully qualified class names. Type handlers. Whenever MyBatis sets a parameter on a prepared statement or retrieves a value from a result set, a type handler is used to retrieve the value in a means appropriate to the Java type. Object factory. Each time MyBatis creates a new instance of a result object, it uses an object factory instance to do so. The default object factory does little more than instantiate the target class with a default constructor or parameterized constructor if parameter mappings exist. If you want to override the default behavior of the object factory, you can create your own. Plugins. MyBatis allows you to intercept calls at certain points within the execution of a mapped statement. By default, MyBatis allows plugins to intercept methods calls of executor, update, query, flush statements, commit, rollback, get transaction, close is closed, and parameter handler, get parameter object, set parameters, result set handler, handle result set, handle output parameters, statement handler, prepare, parameterize, batch, update, query. The details of this classes methods can be discovered by looking at the full method signature of each and the source code which is available with each MyBatis release. You should understand the behavior of the method you are overriding, assuming you are doing something more than just monitoring calls. If you attempt to modify or override the behavior of a given method, you are likely to break the code of to break the core of MyBatis. These are low-level classes and methods, so use plugins with caution. Environments. MyBatis can be configured with multiple environments. This helps you to apply your SQL maps to multiple databases for any number of reasons. For example, you might have a different configuration for your development, test and production environments, or you may have multiple production databases that share the same schema and you would like to use the same SQL maps for both. There are many use cases. It is important thing to remember though, while you can configure multiple environments, you can only choose one per SQL session factory instance. You can see the environment here and transaction manager. There are two transaction manager types. That is type equal JDBC or manage that are included with MyBatis. JDBC, this configuration simply makes use of JDBC commit and rollback facilities directly. It relies on the connection retrieved from the data source to manage the scope of the transaction. Manage, this configuration simply does almost nothing. It never commits or roll back a connection. Instead, it lets the container manage the full lifecycle of the transaction. That is a JEE application server context. By default, it does close the connection. However, some containers don't expect this, and thus if you need to stop it from closing the connection, set the close connection property to false. Data source. The data source element configures the source of JDBC connection objects using the standard JDBC data source interface. Database ID provider. MyBatis is able to execute different statements depending on your database vendor. The multi-DB vendor support is based on the mapped statement database ID attribute. MyBatis will load all statements with no database ID attribute or with a database ID that matches the current one. In case the same statement is found with and without the database ID, the latter will be discarded. Mappers. Now that the behavior of MyBatis is configured with configuration elements, we are ready to define our mapped SQL statements. But first, we need to tell MyBatis where to find them. Java doesn't really provide any good means of auto discovery in this regard, so the best way to do it is to simply tell MyBatis where to find the mapping files. You can use class path relative resource references, fully qualified URL references including file :////URLs, class names or package names. Here you can see a sample mapper.xml and mapper.xml files have only a few first class elements. Cache, configuration of the cache for a given namespace, cache ref, reference to a cache configuration from another namespace, result map, the most complicated and powerful element that describe how to load your objects from the database result sets. Parameter map is deprecated, old school way to map parameters. online parameters are preferred, and this element may be removed in the future, not documented now. And SQL, a reusable chunk of SQL that can be referenced by other statements. Insert, a mapped insert statement. Update, a mapped update statement. Delete, a mapped delete statement. Select, a mapped select statement. And here you can see SQL also. And here you can see a MyBatis -config.xml file here as example, and you can see properties. This file is linked with is connected to properties, settings, type aliases, type aliases, type handlers, object factory, plugins, environments, database, ID provider, and mappers. Environments are connected to transaction manager and data source, and this has one environment here. And mappers are connected to cache ref, result map, parameter map. As an example, you can see here simple example of the configuration file. The configuration XML file contains settings for the core of MyBatis system, including data source for acquiring database connection instances, as well as transaction manager for for determining how transactions should be scoped and controlled. While there is a lot more to the XML configuration file, this example points out the most critical parts. Notice the XML header required to validate XML document. The body of the environment elements contains the environment configuration for transaction manager and connection pooling. The mappers elements contains a list of mappers. The XML files and or annotated Java interface classes that contain SQL code and mapped definitions. As an exception example, we can consider this caused by org.springframework.core.nested.io exception. Failed to pass config resource servlet context resource /web-inf/SqlMap.xml. Nested exception is com.ibatis.common.xml.node exception error passing XML cause java.lang.runtime exception error passing xpath /SqlMapConfig/SqlMap cause java.io.io exception could not find resource web-inf/ad campaign details SqlMap.xml. This error occurred in Spring and MyBatis environment. This as an error example, we can consider this: could not open servlet context resource /MyBatis/SqlMap.config.xml. This error occurred in SSM framework. Now we are focusing on SqlMap.xml. Serves as the SQL mapping file of MyBatis is configured with SQL statement to operate the database. This file needs to be loaded in SqlMapConfig.xml. As an example, you can see here sample account.xml file in MyBatis 2.x version. You can see SqlMap and namespace here, and you can see a result map here, the most complicated and powerful element that describe how to load your object from the database result sets. You can see ID here and ID result, flagging result as ID with help improve overall performance. Both ID and result map a single column value to a single property or field of a simple data type, string, int, double, date, etc. And you can see attribute property here in result, a field or property to map the column result to, and the column name from the database or the aliased column label, and column index here. We can see a select element here, a mapped select element, an ID, a unique identifier in this namespace that can be used to reference the statement. The result map, a named reference to an external result map here, and you can see here insert element, a mapped insert statement, ID is here, and ID attribute, a unique identifier in this namespace that can be used to reference this statement. Here as an example too, you can see here in MyBatis mapper.xml file, sample one. Here mapper namespace is user. Here you can see a select element, a mapped select statement. Here you can see ID, a unique identifier in this namespace. That can be used to reference this statement. We can see here a parameter type, a fully qualified class name or alias for the parameter that will be passed into the statement. And the result type, the fully qualified class name or alias for the expected type that will be returned from the statement. Here you can see insert element, a mapped insert statement. You can see ID here, ID attribute, a unique identifier in this namespace that can be used to reference this statement. Parameter type, the fully qualified class name or alias for the parameter that will be passed into this statement. Flush cache attribute, settings this to be to true will cause the second level and local caches to be flushed whenever this statement is called. Default true for insert, update and delete statement. Timeout attribute, this sets the maximum number of seconds the driver will wait for the database to return from a request before throwing an exception. Default is unset, driver dependent. A configuration file for the MyBatis 2 look like this, and remember that MyBatis loads resources from the class path. So be sure to add the account.xml file to the class path. Here in MyBatis, using class path relative resources, this statement simply tell MyBatis where to go from here. The rest of the details are in each of the SQL mapping files. This segment is from SqlMapConfig.xml. As an exception example, we can consider class SqlMapException thrown to indicate a problem with SqlMap configuration or state. Generally, if an SqlMap exception is thrown, something is critically wrong and cannot be corrected until a change to the configuration or the environment is made. Note, generally this wouldn't be used to indicate that an SQL execution error occurred. That's what SQL exception is for. This is in the package com.ibatis.sqlmap.client. As an error example, we can consider this. The error may exist in mybatis/student.xml. The error occurred while processing mapper underscore result map result. This error occurred in Spring using MyBatis. Now we are focusing on mapper. Mappers are interfaces that you create to bind to your mapped statements. Instances of mapper interfaces are acquired from the SQL session. As such, technically, the broadest scope of any mapper instance is the same as the SQL session from which they were requested. However, the best scope for mapper instances is method scope. That is, they should be requested within the method that they are used and then be discarded. They do not need to be closed explicitly, while it's not a problem to keep them around throughout the request. Similar to the SQL session, you might find that managing too many resources at this level will quickly get out of hand. Keep it simple, keep mappers in the method scope. Here you can see MyBatis lifecycle and scope. It is very important to understand the various scope and lifecycle classes. Using them incorrectly can cause severe concurrency problems. Dependency injection frameworks can create thread-safe transactional SQL sessions and mappers and inject them directly into your bean, so you can just forget about their life cycle. You may want to have a look at MyBatis-Spring or MyBatis Goose subproject to know more about using MyBatis with DI frameworks. Here you can see MyBatis-config.xml. Here you can see a SQL session factory builder. This class can be instantiated, used, and thrown away. There is no need to keep it around once you have created your SQL session factory. Therefore, the best scope for instances of SQL session factory builder is method scope, that is a local method variable. You can reuse the SQL Session Factory builder to build multiple SQL Session Factory instances, but it is still best not to keep it around to ensure that all of the XML parsing resources are freed up for more important things. SQL Session Factory. Once created, the SQL Session Factory should exist for the duration of your application execution. There should be little or no reason to ever dispose of it or recreate it. It's a best practice to not rebuild the SQL Session Factory multiple times in an application run. Doing so should be considered a bad smell. Therefore, the best scope of SQL Session Factory is application scope. This can be achieved a number of ways. The simplest is to use a singleton pattern or static singleton pattern. SQL Session. Each state should have its own instance of SQL Session. Instances of SQL Sessions are not to be shared and are not thread safe. Therefore, the best scope is request or method scope. Never keep references to a SQL Session instance in a static field or even an instance field of a class. Never keep references to a SQL session in any sort of managed scope, such as HTTP session of the servlet framework. If you are using a web framework of any sort, consider the SQL session to follow a similar scope to that of an HTTP request. In other words, upon receiving an HTTP request, you can open a SQL session, then upon returning the response, you can close it. Closing the session is very important. You should always ensure that it's closed within a finally block. Following is a standard pattern for ensuring that SQL sessions are closed. Try open bracket SQL session equal SQL Session Factory dot open session open bracket close bracket open curly bracket, and do the work and close curly bracket. Using this pattern throughout your code will config.xml file is connected to SQL Session Factory Builder. SQL Session Factory Builder is connected to SQL Session Factory. SQL session factory is connected to SQL session, and SQL session is connected to SQL mapper. Here you can see the structure of mapper file. The map file is a configuration file in XML format, which consists of a series of elements with hierarchical relationships, and through the attributes of element there is a correlation between these elements. The details are shown in this figure. In the map file of mapper, the main components are as follows. The mapper element, this element is the top level configuration element, and its attributes namespace point to the full type name of the IDAO class, namely the package path plus class name. Under the mapper element, it contains the following sub elements: result map element, select element, insert element, update element, delete element. Result map element establish a mapping relationship between listing of the database table and data fields of PO category. When the data fields of PO category are inconsistent with the database table, or when carrying complex query result, use result map configuration. Select element used to maintain select sentences statements. Insert element used to maintain insert statements. Update element used to maintain update statements. Delete element used to maintain delete statements. Here DAO is connected to two parts, and here it's connected to namespace. Here the mapper is connected to namespace, and namespace is connected to here, and here ID is connected to here, and the mapper is connected to result map, select, insert, and update and delete. Here ID is connected to select, insert, update and delete. Here the result map is connected to type and ID. Type is connected to PO. Here select is connected to result map is connected to ID, and result here select is connected to result map, and this result map is connected to PO. Here select is connected to parameter type, and parameter type is connected to PO. Here insert is connected to use generated keys, key property and parameter types. Here update is connected to parameter type, and here parameter type is connected to PO, and here delete is connected to parameter type is connected to PO. Here you can see the mapper XML file have only a few first class element in the order that they should be defined. The true power of MyBatis is in the map statement. This is where the magic happens. For all of their power, the mapper XML are relatively simple. Certainly, if you were to compare them to the equivalent JDBC code, you would immediately see a savings of 95% of the code. MyBatis was built to focus on SQL, and thus it's best to stay out of your way. The mapper XML files have only a few class elements in the order that they should be defined. Cache configuration of the cache for a given namespace. Cache reference to a cache configuration from another namespace. Result map, the most complicated and powerful element that describes how to load your object from the database result set. Parameter map deprecated. old school way to map parameters, inline parameters are preferred, and this element may be removed in the future. No, not documented. Also, SQL, a reusable chunk of SQL that can be referenced by other statements. Insert, a mapped insert statement. Update, a mapped update statement. Delete, a mapped delete statement. Select, a mapped select statement. Here you can see a mapper mechanism. When using a mapper interface, the developer can execute SQL only by creating a mapper interface and mapping file. When executing an application, implementation class of mapper interface is generated by MyBatis 3 using the proxy function of JDK. Hence, the developer need not create the implementation class of mapper interface. It is not necessarily to define inheritance and annotation of interface provided by MyBatis for mapper interface, and it can be simply created as Java interface. Example of Java interface. As an the process flow up to SQL execution when mapper interface method is called is shown below here. The mapper mechanism is shown here. One application calls the method defined in mapper interface. The implementation class of mapper interface, proxy object of mapper interface, is generated by MyBatis 3 component at the application startup time. 2. The proxy object of mapper interface calls invoke method of mapper proxy. Role of mapper proxy is to handle the method calling of mapper interface. 3. Mapper proxy generates a mapper method corresponding to the called mapper interface method and calls execute method. The mapper method plays a role of calling SQL session method corresponding to the called mapper interface method. 4. Mapper method calls SQL session methods. When SQL session method is called, a key hereafter referred as statement ID is passed in order to specify SQL statement to be executed. 5. SQL session fetches SQL statement from mapping file using the specified statement ID as key. 6. Session sets the value of the bind variable specified in the SQL statement fetched by mapping file and execute SQL. 7. Mapper interface SQL session converts SQL execution results to Java bean, etc., and returns to the application. When number of records or number of updaters records are to be fetched, primitive type or primitive wrapper type, etc., form the return values. Statement ID is the key to specify the SQL statement to be executed. It is generated accordance with the rule FQCN of mapper interface plus dot plus name of the called mapper interface method. When SQL statement corresponding to the statement ID generated by mapper method is to be defined in the mapper file. It is necessary to specify FQCN of mapper interface in the namespace of mapping file, and method name of mapper interface in ID attribute of various statement tags. Here you can see application service, mapper interface and mapper proxy are inside JDK proxy. Here mapper method, SQL session, mapping file and database. Here one application service is mapper application service is connected to mapper interface via call method, and mapper interface is connected to mapper proxy via invoke 2, and 3 mapper proxy is connected to mapper method via execute. Then mapper method is connected to SQL session via insert, update, delete, select, xxx, and SQL session is connected to mapper file via find SQL statement. Mapper file is connected to SQL session via SQL statement, and then SQL session is connected to database via execute SQL statement, and SQL session is connected to application service via type safe object. Here the mapper proxy, mapper method and SQL session are provided by MyBatis 3. Mapper interface and mapping file is mapping file implements by developer. Now we are considering a mapper execution process. SQL session component, which is a user level API. Users can use SQL session to obtain desired mapper object. Mapper proxy object. When executing the mapper method, mapper proxy will create a corresponding mapper method, and then bottom layer of mapper method is actually a SQL session to execute SQL, but it should be the executor component that actually execute SQL operations. Executor can be understood as a SQL executor which uses statement handler component to operate on JDBC statement object. When the statement type is callable statement and prepared statement, the parameter placeholders will be assigned assigned values through the parameter handler component. Parameter handler component will find the corresponding type handler object according to the Java type, and the type handler will set the value for the parameter parameter placeholder in the statement object through set xxx method, such as set string method provided by the statement object. After statement handler component uses the statement object in JDBC to interact with the database. When the SQL statement type is select, MyBatis obtains the result set object from the statement object through the result set handler component, and then converts the result set object into Java object. We can use diagram to describe the relationship between core component. Here SQL session, execute a statement handler, parameter handler, result set handler, type handler, and configuration are in MyBatis section. Here under JDBC, here result set statement, prepared statement, and callable statements are there. SQL session interacts with executor, executor interacts with statement handler. Statement handler is connected to parameter handler and statements here, and parameter handler is connected to statements, and type handler is connected to statements here, and statements are connected to result set here. Here statement, prepared statement, and callable statement, and result sets is connected to type handler and result set handler. Type handler is connected to result set handler here. Result set handler is connected to statement handler. Here you can see mapper proxy. In MyBatis, our DAO is dynamically proxies through mapper proxy. That is to say that when we execute the method in DAO written by ourselves, the corresponding mapper proxy is actually acting as proxy. Here you can see default is SQL session, actor, configuration, mapper registry, and mapper proxy factory. Here one configuration is connected to mapper proxy via getMapper class SQL session. Mapper proxy is connected to mapper registry. Mapper registry is connected to mapper proxy factory. Mapper proxy factory is connected to itself by new instance. Mapper proxy factory is connected to mapper registry via return mapper proxy. Mapper proxy registry is connected to configuration via return mapper proxy. Configuration actor is connected to default SQL session via getMapper class. Default SQL session is connected to configuration via getMapper class. Configuration is connected to default SQL session via return mapper proxy. Default SQL session is connected to actor via return mapper proxy. Now we are considering mapper responsibility. Here you can see some method signatures and how they are mapped to SQL session. Mappers are interfaces created by users to bind SQL statements. Insert, update, and insert, update, delete, and selects methods. Delete, select, and select methods are all powerful but also a bit cumbersome. A more general way to use the mapper class to execute the mapping statement. A mapper class is an interface class that only needs to declare methods that match the SQL session methods. MyBatis abstract each mapper node in the configuration file as a mapper interface, and the method declared in the interface corresponds to the select, update, delete, and insert node in the mapper node. That is, select the ID value of select the ID value of the update, delete, insert node is the name of the method in the mapper interface. And the parameter type value represents the input parameter type of the corresponding method, and the result result map value correspond to the return value type represented by the mapper interface. So element type of the return result set. MyBatis will generate mapper instance through a dynamic proxy mechanism according to the method information declared by the corresponding interface. MyBatis will determine the statement ID according to the method name, and the parameter type of this method, and then map it to the map it with the SQL session and the bottom layers to complete the interaction with database through the SQL session. This example shows some method signatures and how they are mapped to SQL session. Note the mapper interface does not need to implement any interface or inherit from any class, as long as the methods can be uniquely identified with the corresponding mapping statement. Mapper interface can inherit from other interfaces when using XML to build the mapper interface ensures that statements ensure that statements are contain the appropriate namespace. Moreover, the only restriction is that you cannot have same method signature in two instances. Two inheritance interfaces. Potentially dangerous practice are not advisable. So here xxx.mapper.entityManager.java interacts with xxx mapper.entityMapper.xml. Alias for the parameter that will be passed into the statement. This attribute is optional because MyBatis can calculate the type handler to use out of the actual parameter passed to the statement, default is unset, and result type, the fully qualified class name or alias for the expected type that will be returned from this statement. Note that the case of collections, this should be the type of collection contains, not type of the collection itself. Use result type or result map, not both. This example shows using @select key annotation to retrieve a value from a sequence before insert. Here annotation insert, the annotation that specify a SQL for inserting records. Here this value returns an SQL for inserting records here. This block mapper is in package org.apache.ibatis.domain.block.mappers. As an example, now we are considering annotation interface mapper, marker interface for MyBatis mappers. This is in the package org.apache.ibatis.annotations. Now mappers, for example, here now that the behavior of MyBatis is configured with the configuration elements, we are ready to define our mapped SQL statement, but first we need to tell MyBatis where to find them. Java doesn't really provide any good means of auto discovery in this regard, so the best way to do it is to simply tell MyBatis where to find the mapping files. You can use class path relative resource references, fully qualified URL references, including file : / URLs, class names, or package names, for example here. Here using class path relative resources, using using URL fully qualified paths, using mapper interface classes, register all interfaces in a package as mappers. Now we are considering mapper.xml files. For all of their power, the mapper.xml files are relatively simple. The true power of MyBatis is in mapped statements. This is where the magic happens. For all of their power, the Mapper.xml files are relatively simple. Certainly, if you were to compare them to the equivalent JDBC code, you would immediately see a savings of 95% of the code. MyBatis was built to focus on SQL, and thus it's best to stay out of your way. Mapper.xml files have only few first-class elements in the order that they should be defined: cache, ref, result map, parameter map, deprecated, SQL, insert, update, delete, select. Now we are considering using mappers in Mapper XML files. The following example class demonstrates some method signatures and how they map to the SQL session. Here the t get mapper class t type. While the various insert, update, delete and select methods above are powerful, they are also very verbose, not type safe and not as helpful to your IDE or unit test as they could be. We have already seen an example of using mappers in the previously. Therefore, a more common way to execute map statement is to use mapper class. Mapper classes. A mapper class is simply an interface with method definitions that match up against the SQL session methods. The following example class demonstrates some method signatures and how they map to the SQL session. In a nutshell, each mapper method signature should match that the SQL session method match that of the SQL session method that it's associated to, but without string parameter ID. Without string parameter ID. Instead, the method name must match the mapped statement ID. In addition, the return type must match that of the expected result type for a single result, or an array or collection of multiple results or a cursor. All of the usual types are supported, including primitives, maps, pojos, and Java beans. Note mapper interface. Mapper interfaces do not need to implement any interface or extend any class, as long as the method signature can be used to uniquely identify the corresponding mapped statement. Note mapper interfaces can extend other interfaces, but sure that you have the statement in appropriate namespace when using XML binding to mapper interfaces. Also, the only limitation is that you cannot have the same method signature in two interfaces in a hierarchy. A bad idea anyway. You can pass multiple parameters to mapper method. If you if you do, they will be named by the literal param followed by their position in the parameter list by default. For example, hash param 1, hash param 2, etc. If you wish to change the name of the parameters, multiple only, then you can use @param name annotation on the parameter. You can also pass row bounds instance to method to limit query results. Here author select one. Here author select one, select author 5 here. Here list author, select list and select authors. Here map integer author. select map, select authors ID. Here insert author and author. Here update author, delete author 5 here. Now we are considering pluggable scripting language for dynamic SQL. Or in case you are using mappers using atlang and annotation. Annotation interface lang, the annotation that specify a language driver to use. This in the package org.apache.ibatis.annotations. Starting from version 3.2, MyBatis supports pluggable scripting languages, so you can plug a language driver and use that language to write your dynamic SQL queries. You can plug a language by implementing following interface. Once you have custom language driver, you can set it to be default by configuring it in MyBatis-config.xml file. Instead of changing the default, you can specify language for any specific statement by adding lang attribute as well, lang attribute, and or in the case you are using mappers using atlang annotation. Note, you can use Apache Velocity as your dynamic language. Have a look at the MyBatis-Velocity project for the details. All the XML tags you have seen in this. Now we are considering configure logback in step 2 in logging configuration. Suppose you want to enable log for this mapper. Create a file called logback.xml as shown here and place it in your class path. This file will cause log slf4j logback to report details login for org.mybatis.example.blog mapper and just errors for the rest of the class of your application. Here you can see a configuration example for log4j2. Here you can see configuration example for log4j. Here you can see configuration example for JDK logging. Here the login.properties. Exception, we can consider binding exception. It's in package org.apache.ibatis.binding. As an error example, we can consider invalid bound statement not found. Now we are focusing on mapped statement. Map statement can hold any SQL statement and can use parameter maps and result maps for input and output. Here you can see how to communicate SQL written in XML, SqlMap.xml in iBatis with DB. in the way of programming using existing JDBC, SQL statements were written in the program source, but using IBATIS, the SQL statements are separated from the program and written separately in XML file. This reduces the burden of programmers programming when using existing JDBC. In addition, if the user wants to change the SQL can be changed freely because the user only needs to change the SQL statement in the SQL files in the XML file rather than modifying the program as before. When user writes the each SQL statement for CRUD in SqlMap.xml XML file and writes these files in SqlMap.Config.xml file, it's automatically create mapped statements objects through IBATIS API and execute SQL statements in DB through it. Int or integer and returns a HashMap keyed by column names mapped to raw values. As an example 2, we can consider this. This annotation type intercept, the annotation that specify target methods to to intercept, and this is in package org.apache.ibatis.plugin. This annotation type signature, the annotation that indicate the method signature. The type element is returns the Java type, and method returns the method name, and args returns Java types for method arguments. And here implements pre-processing if needed, and implement post-processing if needed here, before and after invocation that proceed. As a class mapped statement, this is in the package org.apache.ibatis.mapping. Now we are considering exploring mapped SQL statement. Here is an example of XML based map statement that would satisfy the SQL session calls. At this point you may be wondering what exactly is being executed by the SQL session or mapper class. The topic of mapped SQL statement is a big one, and that topic will likely dominate the majority of this talk. But to give you an idea of what exactly is being run, here is a couple of examples. In either of the examples here, the statement would have been defined by either XML or annotations. Let's take a look at XML. The full set of features provided by MyBatis can be realized by using XML based mapping language that has made MyBatis popular over the years. If you have used MyBatis before, the concept will be familiar to you, but there have been numerous improvements to the XML mapping documents that will become clear later. Here's an example of an XML based mapped statement that would satisfy the above SQL session calls. While this look like a lot of overhead for this simple example, it's actually very light. You can define as many mapped statement in a single mapper XML file as you like, so you get a lot of mileage of the map XML header and doc type declarations. The rest of the file is pretty self-explanatory. It defines the name for the mapped statement select block in the namespace. mybatis.example.blockmapper, which would allow you to call it by specifying fully qualified name of org.mybatis.example.blockmapper.selectBlock. Here's one of the more trick the mapper classes like blockmapper. One second. Here, sorry. Notice how similar this is to calling method on a fully qualified Java class, and there is a reason for that. This name can be directly mapped to the mapper class of the same name as the namespace, with the method that matches this name parameter and return type as the mapped select statement. This allows you to very simply call the method against the mapper interface as you so above here, but there's again in the following example. The second approach is has a lot of advantage. First, it doesn't depend on string literal, so it's much safer. Second, if your IDE has code completion, you can leverage that when navigating your maps SQL statements. A note about namespaces. Namespaces were optional in previous versions of MyBatis, which was confusing and unhelpful. The namespaces now required and have a purpose beyond simply isolating statement with longer fully qualified names. A namespace enables the interface binding as you see here, and even if you don't think you will use them today, you should follow these practices laid out here in the case of change your mind. Using the namespace once and putting it in a proper Java package namespace will clean up your code and improve the usability of MyBatis in long term. Namespace resolution. To reduce the amount of typing, MyBatis uses following name resolution rules for named configuration elements, including statement, results map, and caches, etc. Fully qualified name, for example, com.mypackage.mymapper.select all things are looked up directly and used it if it found. Short name select all things, for example, can be used to reference an unambiguous entry. However, if there is two or more, for example, com.foo.select all things and com.bar.select all things, then you will receive an error reporting that the short name is ambiguous and therefore must be fully qualified. Here we are considering select in mapper.xml files. For example, here the select statement is one of the most popular elements that you will use in MyBatis. Putting data in the database isn't terribly valuable until you get back it out. So most application query far more than they modify the data. For every insert, update or delete, and there are probably many selects. This is one of the following principles of MyBatis and is the reason so much focus and effort was placed on querying and result mapping. The select statement is quite simple for simple cases. For example, here the statement is called select person, takes parameter of type int or integer and returns the HashMap keyed by column names mapped to row values. Notice the parameter notation ID. This tells the MyBatis to create prepared statement parameter. With JDBC, such a parameter would be identified by question mark in SQL passed to a prepared statement, something like this. Of course, there is a lot more code required by JDBC alone to extract the result and map them to an instance of an object, which is what MyBatis saves you from having to do. There's a lot more to know about parameters and result mapping. Here the attribute ID, the unique identifier in this namespace that can be used to reference this statement. Parameter type, the fully qualified class name or alias for the parameter that will be passed into this statement. This attribute is optional because MyBatis can calculate the type handler to use out the actual parameter passed through the statement. Default is unset. Result type, the fully qualified class name or alias for the expected type that will be returned from this statement. Note that in the case of collection, this should be the type that collection contains, not the type of collection list itself. Use result type or result map, not both. Similar JDBC code, not MyBatis. Now we are considering insert, update and delete. The following are some examples of insert, update and delete statements. The data modification statement, insert, update and delete are very similar to their implementation. Here the ID, a unique identifier in this namespace that can be used to reference this statement. The following are some examples of insert, update and delete statements. As mentioned, the insert is little bit more rich in that it has few extra attributes and sub elements that allow to deal with key generation in a number of ways. Now we are considering SQL. For example, here this element can be used to define a reusable fragment of SQL code. That can be included in other statement. It can be statistically during load pace parameterized. The difference property values can vary in include state instances. For example, here SQL fragment can then be included in another statement, for example. Select users here, select ID, sorry. Now we are considering cache here using a custom cache. By default, statement are configured like this, and MyBatis include the powerful transactional query caching feature, which is very configurable and customizable. A lot of changes have been made in the MyBatis 3 cache implementation to make it both more powerful and far easier to configure. By default, just the local session caching is enabled, that is used solely to cache data for the duration of a session. To enable global level caching, simply need to add one line to your SQL mapping file. So here that line is cache, just simply this open open angle bracket cache, then / and then close angle bracket. Basically that is the effect on of one simple statement. It as follows: all result from this select statement or mapped statement file will be cached. All insert, update, delete statement will be mapped statement file will be flushed to the cache. The cache will use a least recently used LRU algorithm for eviction. The cache will not flush on any sort of time-based schedule, that is no flush interval. Cache will store 124 references to list of objects whatever the query method returns. Cache will be treated as a read-write cache, meaning objects retrieved are not shared and can be safely modified by the caller without interfering it with other potential modification by other callers or threads. Note the cache will only apply to statement declared in the mapping file where the cache tag is located. If you are using Java API in conjunction with XML mapping file, then statement declared in companion interface will not be cached by default. You will need to refer to the cache region using @cache namespace ref annotation. All these properties are modifiable through attributes of the cache element. For example, here more advanced configuration creates FIFO cache that flushes once every 60 seconds, stores up to 512 references to result object or lists, and object returns are considered read-only. Thus modifying them could cause conflict between callers and different threads. The available eviction policies are available LRU, least recently used, removes object that haven't been used for the longest period of time. FIFO, first in first out, removes object in order that they entered the cache. Soft reference, remove the object based on the garbage collected state and the rules of soft references. Weak reference more aggressively removes object based on the garbage collected state and rules of weak references. Default is LRU. Flush interval can be set to any positive integer and should represent a reasonable amount of time specified in milliseconds. The default is not set and thus no flush interval is used, and the cache is only flushed by calls to the statement. Size can be set to any positive integer. Keep in mind the size of the object you are caching is available memory resources of your environment. The default is 1024. The read-only attributes can be set to true or false, and read-only cache will return the same instance of cache object to all callers. Thus, the object should not be modified. This offers a significant performance advantage, though. A read-write cache will return only a copy via serialization of the cached object. This is slower but safer, and thus the default is false. Note the second level cache is transactional. This means that it is updated when a SQL session finishes. SQL session finishes the commit, or when it finishes with rollback, no insert, update, insert, delete, updates with flush cache equal true executed. Using a custom cache, in addition to customizing the cache in these ways, you can completely override the cache behavior by implementing your own cache or creating an adapter to their third-party cache solutions. It is important to remember that cache configuration and cache instances are bound to the namespace of the SQL map. Thus, all statements in the same namespace as the cache are bound by it. Statement can modify how they interact with the cache. or exclude themselves completely by using two simple attributes. So on the statement by statement basis, by default the statements are configured like this. Since that's the default, you obviously should never explicitly configure a statement that way. Instead, only set the flush cache and use cache attributes if you want to change default behavior. For example, in some cases you may want to exclude the result of a particular select statement from cache, or you might want to select statement to flush flush the cache. Similarly, you may have some update statement that don't need to flush upon execution. Now we are considering dynamic SQL. If in dynamic SQL, for example, here the most common use thing to do in dynamic SQL is conditionally include the part of a where clause. For example, here the statement would provide an optional text search type of functionality. If you passed in no title, then all active blogs would be returns. But if you pass a title, it will look for a title like that for the keen-eyed. Yes, in this case your parameter value would need to include any masking or wildcard characters. Now we are considering choose when otherwise. If neither is provided, let's only return featured block, perhaps the strategically list selected by administrator, instead of returning huge meaningless list of random blocks. Sometimes we don't want all the conditions to apply. Instead, we want to choose only one case among many options. Similar to the switch statement in Java, MyBatis offers a choose statement. Let's use the example here. But how? Let's search only on title if one is provided, then only by author if and then only by author if one is provided. If neither is provided, let's only return featured blogs, perhaps the strategically list selected by administrator, instead of returning a huge meaningless list of random blocks. Now we are considering trim, where, and set. Consider what would happen if we return to our if example, but this time we make active equal 1 a dynamic condition as well. The previous example have been conveniently dancing around the notorious dynamic SQL challenge. Consider what would happen if we return to our if example, but this time we make active equal 1 a dynamic condition as well. What happen if none of these conditions are met? You would end up with SQL that look like this. And what if this would fail? What if only the second condition was met? You would end up a SQL like the SQL that look like this. This would also fail. This problem is not easily solved with conditionals, and if you ever had to write it, then you likely never want to do so again. MyBatis has a simple answer that will likely work in 90% of cases, and in cases where it doesn't, you can customize it so that it does. With one simple change, everything work fine. The where element knows to only insert where if there is any content returned by the containing tags. Furthermore, if that content begins and or it knows to strip it off. If where element does not behave exactly as you like, you can customize it by defining your own trim element. For example, the trim element to where element is prefix overrides attribute takes a piped delimited list of text to override where white space is relevant. This result is the removal of anything specified in the prefix override attribute and the insertion of anything that prefix attribute. There is a similar solution for dynamic update statements called set. The set element can be used to dynamically include columns to update and leave out others. For example, here the set element will dynamically prepend the set keyword and also eliminate any external commas that might trail the value assignment after conditions applied. Alternatively, you can achieve the same effect by using trim element. Notice that this case we are overriding suffix while they were still appending a prefix. We can consider for each, for example, here. Another common necessary for dynamic SQL is we need to iterate over collection. Often to build an in condition, for example, here. The for each element is very powerful and allows you to specify a collection, declare an item, and index variables that can be used inside the body of the element. It also allows you to specify opening and closing strings and add separator to place between iterators. The element is smart in that won't accidentally append extra separators. Note, you can pass any iterable object for example list, set, etc., as well as any map or array object for each as a collection parameter. When using iterable or array, index will be the number of the current iteration and value item will be the element retrieved in this iteration. When using a map or a collection of map.entry object, index will be the key object and the item will be the value object. This wrap up the discussion regarding XML for each here. We are considering now script, for example here. For using dynamic SQL in annotated mapper, annotated mapper class, script element can be used for example. Here we are considering bind, for example here. The bind element lets you to create variable out of OGNL expression and bind it to the context, for example here. Now we are considering multi-DB vendor support. Have a look at the following example. If the database ID provider was configured, underscore database ID variable is available for dynamic code, so you can build different statements depending on the database vendor. Have a look at the following example. Now we are considering pluggable scripting languages for dynamic SQL. Instead of changing the default, you can specify the language for a specific statement by adding a lang attribute as follows. The interface lang driver in package org.apache.ibatis.scripting. Starting from version 3.2, MyBatis support pluggable scripting languages, so you can plug a language driver and use that language to write your dynamic SQL queries. You can plug a language by implementing language driver interface. Once you have custom language driver, you can set it to be the default by configuring it in MyBatis-config.xml file. Instead of changing the default, you can specify language for the specific statement by adding lang attribute as follows. Or in the case you are using mappers, you can use @lang annotation. You can use Apache Velocity as a dynamic language. Have a look at the MyBatis-Velocity project for the details. All the XML tags you have seen in the sections are provided by the default MyBatis language that is provided by the driver org.apache.ibatis.scripting.xml tags.xml driver, which is aliased as XML. Now we are considering SQL execution methods in SQL session, and in SQL sessions, a cursor offers the same results as a list, except it fetches data lazily using an iterator. These methods are used to execute select, insert. Now we are in statement execution methods. These methods are used to execute select, insert, update, and delete statement that are defined in your SqlMapConfig.xml file. They are pretty self-explanatory. Each takes the ID of the statement and parameter object, which can be primitive, autobox, wrapper, a Java bean, or poacher, or a map. The difference between select one and select list is the only that select one must return exactly one object, and object or null and none. If there's more than one, an exception will be thrown, and if you don't know many objects are expected, select list. Expected to use select list. If you want to check the existence of an object, you are better off running count 0, 1. If you want to check the existence of an object, you are better off running 0, 1. The select map is special case in that it is designed to convert a list result into a map based on one of the properties in the resulting object, because not all statements require a parameter. These methods are overloaded with versions that do not require one parameter object. Value returned by insert, update, and delete methods indicate number of rows affected by the statement. Cursor offers the same results as a list. It fetches data lazily using iterator. Finally, there are 3 advanced versions of select methods that allow you to restrict a range of rows returned or provide custom results handling logic, usually for every data sets. Row bounds parameter causes MyBatis to skip the number of records specified, as well as limit the number of results returned to some number. Now we are considering batch update statement flush method. This method can be used when executor type is executor type.batch. The flush statement, the list batch result flush statement method flushes batch statement. This is in the interface SQL session, and which is in the package org.apache.ibatis.scripting. session. There's a method for flushing executing batch update statement that I stored in JDBC driver class at any time. This method can be used when executor type is executor.batch. Here, this one. Now we are considering transaction control methods. However, if you are using JDBC transaction manager managed by the connection instance, then the 4 methods that will come in handy to use. Void commit, the flushes back statement and commits database connection. Note that database connection will not be committed if no updates and deletes inserts were called. To force the commit, call commit boolean. Void commit boolean force. Flushes batch statement and commit database connection. Void rollback, discards the pending batch statement and rolls the database connection back. Note that database connection will not be rolled back if no updates, deletes, insert were called. To force the rollback, call rollback boolean. Void rollback boolean force. Note that boolean discards the pending batch statement and roll back database connection back. Note that the database connection will not be rolled back if no updates, deletes, inserts were called. These are in the interface SQL session and in the package org.apache.mybatis.session. There are 4 methods for controlling scope of a transaction. Of course, these have no effect if you are chosen to use auto commit or if you are using external transaction manager. However, if you are using JDBC transaction manager managed by connection instance, then 4 methods that will come in handy are these. By default, MyBatis does not actually commit unless it detects that the database has been changed by a call to insert, update, delete, or select it affect data enabled. If you are somehow made changes without calling these methods, then you can pass through into commit or rollback methods to guarantee that they will be committed. Note that you still can force sessions or in auto commit node, or note that using external transaction manager, most of the time you won't have to call rollback, as MyBatis will do that for you if you don't call commit. However, if you need more fine-grained control over the session where multiple commits and rollbacks are possible, you have a rollback option there to make that possible. MyBatis-Spring and MyBatis-Goose provide declarative transaction handling, so if you are using MyBatis with Spring or Goose, please refer to their specific manuals. Now we are considering local cache. You can clear the local cache at any time by calling void clear cache method, clears local session cache. This is in the interface SQL session and in the package org.apache.mybatis.session. MyBatis uses 2 caches, local cache and second level cache. Each time new session is created by MyBatis, create a local cache and attach it to the session. Any query executed within a session will be stored in the local cache, so further execution in the same query at the same input parameters will not hit the database. The local cache is cleared upon commit, update, commit, rollback, or close. By default, local cache is used for the whole session duration. This cache is needed to resolve clear references to speed up the repeated nested queries, so it can never be disabled, but you can configure the local cache to be used just for the duration of a statement executed by local cache scope equals statement. Note that when the local cache scope is set to session, MyBatis return references to the same object which are stored in the local cache. Any modification of the return object, list, etc. influences the local cache contents and subsequently the values which are returned from the cache in the lifetime of the session. Therefore, as best practice, do not modify the object returned by MyBatis. You can clear the local cache at any time by calling void clear cache. Now we are considering ensuring that SQL session is closed. The best way to ensure this is to use the following unit of work pattern. Void close, the most importantly thing you must ensure to close any session that you open. The best way to ensure this is to following the unit work of pattern. Just like SQL Session Factory, you can get the instance of configuration. That session is used by calling getConfiguration method. The following 3 lines are pseudocode for doing some work. Now we are considering using mappers. The following example class demonstrates some method signatures and how they map to the SQL session. The various insert, update, delete, and select method are powerful. They can also be very verbose, not type safe, and not helpful to your IDE or unit test as they could be. You have therefore a more common way to execute map statement is use mapper classes. A mapper class is simply an interface which method definitions that match up against the SQL session methods. For example, class demonstrate some method signatures and how they map to SQL session. In a nutshell, the mapper method signature should match the SQL session method that's associated to but without string parameter ID. Instead, the method name must match the mapper statement ID. In addition, the return type must match the expected result type for the single result or an array of collection for multiple result or cursor. All of the usual types are supported, include primitives, maps, pojos, and Java beans. Note the mapper interface do not need to implement any interface or extend any class as long as the method signature can be used. Uniquely identify the corresponding map statement. Mapper statement interfaces can be extend other interfaces. Be sure that you have statement to appropriate namespace when using XML binding to a mapper interfaces. Also, only limitation is that you cannot have same method signature in 2 interfaces in a hierarchy. A bad idea anyway. You can pass multiple parameters to a mapper method. If you do, they will be named by a literal param followed by their position in the parameter list by default. For example, hash param 1, hash param 2, etc. If you wish to change the name of the parameter, multiple only, you can use the @param param name annotation on their parameter. You can also pass as a row bound instance to the method to limit query results. Now we are considering SQL builder class. The solution here, for example, problem above look like this when rewritten with the SQL classes. The class SQL, this is in the package ogre.mybatis.jdbc. One of the nastiest things the Java developer will ever have to do is embedded SQL in Java code. Usually this is done because the SQL has to be dynamically generated. Otherwise, you could externalize it in a file or a stored procedure. As you have already seen, the MyBatis has a powerful answer for dynamic generation in XML file, XML mapping features. However, sometimes it becomes necessary to build SQL statement string inside the Java code. In this case, MyBatis has one more feature to help you out before reducing yourself to the typical mess of the plus signs, quotes, new lines, formatting problems, and nested conditional to deal with extra commas and and conjunctions. Indeed, dynamically generating SQL code in Java can be a real nightmare. For example, here the solution, MyBatis 3 offers convenient utility class to help with this problem. With the SQL class, you can simply create an instance that lets you to call methods against it to build SQL statement one step at a time. Example problem above would look like when written with SQL class here. When what is so special about that example? Well, if you look closely, it doesn't have to worry about accidentally duplicating and keywords. Or choosing them where and or none at all. The SQL class takes care of understanding where needs to go and should be used and all of the string concatenation. Now we are considering SQL class. Here are some examples. Here delete from method start to delete statement and specify table to delete from. Generally this should be followed by where statement. Where string appends the new where clause condition concatenated by and can be called multiple times, which causes it to concatenate new conditions each time with and, or use O method to split with an O. Insert into string, start and insert a statement and specify table to start into. This should be followed by one or more values method or into column method or into values calls. Values method appends an insert statement. First parameter is the columns to insert, and The second parameter is values. Select strings start or appends the select clause, then can be called more than once, and parameters will be append to the select clause, and parameters are usually comma separated list of columns and aliases, but can be anything acceptable to the driver. From string start or appends to a from clause can be called more than once, and parameters will be append to the from clause. Parameters are usually a table name, an alias, or anything separated to the driver. Order by string appends a new order by clause elements, a concurrent data with comma, can be called multiple times, which causes it to concatenate new conditions each time with the comma. Delete from, start the delete statement and specify a table to delete from. Generally this should be followed by where statement. Update string start an update statement and specify the table to update. This should be followed by one or more set method calls, and usually where method call. Set append a set list to update statement. Note, it is important to note that SQL class writes limit offset in and rows, fetch first and rows only classes to generate into the generated statement as is. In other words, the library does not attempt to normalize those values for a database that don't support these clauses directly. Therefore, it is very important for users to understand whether or not the target database supports these clauses. If the target database does not support these clauses, then it's likely that using this support will cause SQL that has runtime errors. Anonymous inner class here. Builder fluent style. With conditionals, not the final parameter required for anonymous inner class to access them. Now we are considering SQL builder and select builder deprecated. Before version 2. Deprecated, this allows us to create methods like this. Select builder is in package org.apache.ibatis.jdbc, and SQL builder is in the package org.same package org.apache.ibatis.jdbc. These are deprecated. Use the SQL class. Before version 3.2, we took a bit of a different approach by utilizing a thread local variable to mask some of the language limitations that make Java DSLs a bit cumbersome. However, this approach is now deprecated as modern frameworks have warned people the idea of using builder type patterns and anonymous inner classes for such things. Therefore, the select builder and SQL builder classes are now have been deprecated. Following methods apply to only deprecated SQL builder and select builder classes. Begin these methods clear the thread local state of the select builder class. Reset method begin or reset. These methods clear thread local state and builder class and prepare it for new statement to be built. Begins reads the best when starting a new Statements reset method reads the best when clearing a statement in the middle of execution of some reason, perhaps if the logic demands a completely different statement under some conditions. SQL, this returns the generated SQL and resets the select builder state as if begin method or reset method call. Thus this method can only be called once. Select builder and SQL builder classes are not magical, but it's important to know how they work. Select builder and SQL builder use combination of static imports and local thread variables to enable the clean syntax that can be easily interlaced with conditionals. Use them for use statistically import the method from classes like one or the other, not both. This allows us to create methods like this: deprecated, clears the thread local variable, exception example we can consider this occurred in Spring and MyBatis. Java.land.illegal argument exception mapped statement collection does not contain value for com.thong lm1.spring.mappers.order.mappers.get all order at org.apache.ibatis.session.configuration $strict-map.get configuration.java 672 org.apache.ibatis.session.configuration.get mapped statement configuration.java 5 or 6 at etc. As an array example, we can consider this: mapped statement collection does not contain value for mapper dot batch customer dot find batch customer 1-1. Now we are focusing on HashMap and dictionary as input. HashMap, hash table based implementation of the map interface. This implementation provides all of the optional map operations and permits null values and the null key. The HashMap class is roughly equivalent to hash table, except that it is unsynchronized and permits nulls. This class makes no guarantees as to the order of the map. In particular, it does not guarantee that the order will remain constant over time. Dictionary. The dictionary class is the abstract parent of any class, such as hash table, which maps keys to values. Every key and every value is an object. In any one dictionary object, every key is associated with an at most one value. Given a dictionary and a key, the associated element can be looked up. Any null object can be used as a key and as a value. Here you can see the difference between HashMap and hash table in Java. The HashMap and hash table both are used to represent a group of objects that are represented in key value pair. Each key value pair is called entry object. The collection of entries is referred by the object of HashMap and hash table. Keys in a collection must be unique or distinctive. The difference between HashMap and hash table is that HashMap particularly implements the map interface, whereas the hash table extends the dictionary class legacy class, which is re-engineered to implement map interface. The other important difference is that objects of HashMap are unsynchronized, whereas the objects of hash table is synchronized. As an example, we can consider this one. The value of key in a map can be obtained without adding value characters such as hash and $, in text expression, while the value of the value of a key in a map can be obtained by writing directly like this, while in other places it is necessary to have hash key in a map to obtain the value of key in a map. Pre-name code and class equal HTML. Yeah. The map parameter passed to MyBatis in the background. Don't dwell into function meaning. It is enough to know that the following map is finally passed to parameter type in MyBatis. Parameter type attribute. The fully qualified class name or alias for the parameter that will be passed into the statement. This attribute is optional because MyBatis can calculate the type handler to use out of the actual parameter passed to the statement. Default is unset. Now we are considering aliases in configuration. HashMap here. The map type is HashMap here. As an error example, we can consider this one. Type handler was null on parameter mapping for property underscore frch underscore item underscore 0 dot value. It was either not specified or could not be found for the Java type JDBC type combination specified. Now we are focusing on Java or .NET objects as input. Java object. A Java object is a member, also called an instance of a Java class. .NET object. An object is an instance of a particular class. As an example, we can consider this one. If a parameter object of a type user was passed into that statement, the ID, username, and their username and password property would be looked up, and their values passed into a prepared statement parameter. As an example too, we can consider this segment. This is Oracle sequence example using .NET 1.1 system.data.oracle client. So this is a .NET example. And here parameter class is product here. Here you are considering type aliases in mapper.xml files. Here the object and map type is object. Now we are considering parameters in mapper.xml files. For example, here however, if you pass a complex object, then the behavior is a little different here. If a parameter object type user was passed into the statement, the ID, username, and password property would be looked up, and their values passed to prepared statement parameter. That's nice and simple for passing parameters into statement, but there are a lot of other features of parameter types. First, like other of MyBatis, parameters can specify a more specific data type. Like rest of the MyBatis, the Java type can almost always be determined from the parameter object unless that object is HashMap. Then the Java type should be specified to ensure the correct type handler is used. Note the JDBC type is required by JDBC for all nullable columns. If null is passed as a value, you can investigate this yourself by reading the Java docs for the prepared statement.setNull method. Now we are focusing on primitive or simple as input string, int, string, date, etc. Int Java type is java.lang.long. CLR type is system.int64. String Java type is java.lang.string. CLR type is java system.string. Date Java type is java.sql.date in general. CLR type is system.datetime. As an example, we can consider this one. This statement is called select person, takes a parameter of type int and returns a HashMap keyed by column names mapped to row values. Here the parameter type is int and corresponding Java type is java.lang.long. As an example 2, we can consider this. Here the Java type is java.lang.long. An annotation type param, the annotation that specify the parameter name. Here returns the parameter name. Here it int and Java corresponding Java type is java.lang.long. As an example 3, we can consider this one. Here the corresponding Java type is java.lang.string and this parameter is string. As example 4, we can consider this. Parameter type is date and corresponding Java type is generally java.sql.date. Here now we are considering aliases in type aliases in configuration. They all are case sensitive. There are many built-in type aliases for common Java type. They all are case sensitive, not the special handling of primitive due to the overloaded names. Now we are considering string substitution in parameters in mapper.xml files. By default, using hash open curly brace close curly brace syntax will cause MyBatis to generate prepared statement properties and set the values for set the value safety against prepared statement parameters. For example, question mark. While this is safe, faster and almost always preferred, sometimes we just want to directly inject an unmodified string into SQL statement. For example, for order by, you might use something like order by $column name. Here MyBatis won't modify or escape the string. String substitution can be very useful when metadata, that is table name and column name in SQL statement, is dynamic. For example, if you want to select from a table by any one of its columns, instead of writing code like here, you can just write in which the column will be substituted directly and the value will be prepared. Thus you can just do the same work by here. This idea can be applied to substitute the table name as well. Note, it's safe to accept input from a user and supply it to a statement unmodified. In this way, this leads to potential SQL injection attack, and therefore you should either disallow user input in these fields or always perform your own escapes and checks. And more find by XXX methods here, this one. As an error example, we can consider this cause com.mysql.jdbc.mysql data truncation, Java truncation incorrect, date time value 3892-04-19 00:00:00 for column register underscore time at row 1. As an output, we are considering HashMap and dictionary as output. HashMap, hash table based implementation of the map interface. This implementation provides all the optional map operations and permits null values and null key. The HashMap class is roughly equivalent to hash table, except that it is unsynchronized and permits nulls. This class makes no guarantees as to the order of the map. In particular, it does not guarantee that the order will remain constant over time. Dictionary. The dictionary class is the abstract parent of any class, such as hash table, which maps keys to values. Every key and every value is an object in any one dictionary object. Every key associated with at most one value. Given a dictionary and a key, the associated element can be looked up. Any non-null object can be used as a key and as a value. Here you can see the difference between HashMap and hash table in Java. HashMap and hash table both are used to represent a group of objects that are represented in key value pair. Each key value pair is called entry object. The collection of entries is referred by the object of a HashMap and hash table. Keys keys in a collection must be unique or distinctive. Difference between HashMap and hash table is that HashMap particularly implements the map interface, whereas the hash table extend the dictionary class, legacy class, which is re-engineered to implement map interface. The other important difference is that objects of HashMap are unsynchronized, whereas the object of hash table are synchronized. As an example, we can consider this. such a statement simply result in all columns being automatically mapped to keys of a hash map as specified by the result type attribute result type, the fully qualified class name or alias for the expected type that will be returned from this statement. Note that in the case of collections, this should be the type that the collection contains, not the type of the collection itself. Use result type or result map, not both. Now we are considering result maps in XML mapper files. For example, here the result map element is the most important and powerful element in MyBatis. It's what allows you to do away with 90% of the code that JDBC requires to retrieve the data from result sets, and in some cases allow you to do things that JDBC does not even support. In fact, to write an equivalent code for something like a join mapping for a complex statement could probably span thousands of lines of code. The design of the result map is such that the simple statement don't require explicit result mapping at all, and more complex statements require no more than absolutely necessary to describe the relationships. Here the statements result all. Here MyBatis supports the consider the following Java bean here. Based on the Java bean specification, and the above class has three properties: ID, username, and hash password. This match up exactly with the column names in the select statement. Such a Java bean could be mapped to a result set just as easily as a hash map. The great thing about result map is that you have already learned about a lot about them, but you haven't seen one yet. This simple case don't require any more than you have seen here. Just for example, let's see what this last example would look like as an external result map. That's another way to solve the column name mistakes. And here and a statement that references it uses result map attribute to do so. Notice we remove result type attribute, for example, here. We have already seen examples of simple map statement that don't have explicit result map. For example, here such a statement simply result all columns being automatically mapped to a keys of HashMap as is specified by a result type attribute. While useful in many cases, a HashMap doesn't make a very good domain model. It's more likely that your application will use Java beans or POJOs, plain old Java objects for domain model. MyBatis supports both. As an error example, we can consider this: expected one result or null to be returned by select one but found, etc. This error was returned while returning HashMap of result in MyBatis rather than list. Now we are focusing on Java or .NET object. Java object. A Java object is a member, so-called an instance of a Java class. .NET object, an object is an instance of a particular class. As an example, we can consider this one. A Java bean could be mapped to a result set just as easily as the HashMap. Here you can see user. As example 2, we can consider this one. This is an .NET object in .NET platform. The result class is class.name or alias. We are now considering a result map in map.xml file. Such a Java bean could be mapped to a result set just as easily as HashMap. Here, consider the following Java bean. Based on the Java bean specification, above class has three properties: ID, username, and hash password. These match up exactly with the column names in the select statement. Such a Java bean could be mapped to a result set just as easily as HashMap. Now we are considering advanced result maps. MyBatis was created with one idea in mind. Database aren't always what you want or need them to be. While we have allow every database to be perfect third model toward normal form or BCNF, they aren't. It would be great if it was possible to have a single database map perfectly to all of the application that use it. It's not. Result maps are the answer that MyBatis provides to this problem. For example, how would we map this statement. You would probably want to map it to an intelligent object model consisting of a blog that was written by an author and has many posts each of which may have 0 or many comments and tags. The following is a complete example of complex result map. Assume author, blog, post, comments, tags are all type aliases. Have a look at it, but don't worry, we are going to go through each step. While it may look daunting at first, it's actually very simple. Here the very complex statement. It's a very complex result map. The result map element has a number of sub-elements and a structure worthy of some discussion. The following is a conceptual view of result map element. Result map, here the constructor is used for injecting result into the constructor of a class upon instantiation. Here ID argument flagging result as ID will help it improve overall performance. If we have args, a normal result injected into constructor. ID and ID result flagging results as ID will help improve overall performance. The result, a normal result injected into a field or Java Beam property. Association, a complex type association, many results will roll up into this type. Nested result mappings, associations are result maps themselves or can refer to one. Collection used as a value to determine which result map to use. Nested result mapping collections are result maps themselves or can refer to one. Discriminator uses a result value to determine which result map to use. Case, a case is a result map based on some value. Nested result mapping, a case is also a result map itself and thus can contain many of this same element, or it can refer to an external result map. Attributes ID, a unique identifier in this namespace, can be used to reference this result map. Type, fully qualified Java class name or type aliases. If you have auto mapping, If present, MyBatis will enable or disable the auto mapping for this result map. These attributes override the global auto mapping behavior default unset. Here a very complex result map here. Now we are considering result map always build result maps incrementally. Unit test really help out there. If you try to build a gigantic result map like one we previously described at all at once, it's likely you get it wrong and it will be hard to work with. Start simple and evolve it a step at a time, and unit test. The downside to use frameworks is that they are sometimes a bit of a black box, open source or not. Your best bet to ensure that you are achieving the behavior that you intend is to write unit test. It also helps to have them when submitting bugs. Now we are considering ID and result. These are most basic of result mappings. These are the most basic result mapping. Both ID and result map a single column value to a single property or field of a simple type, integer, double, date, etc. Only difference between the two is that ID flag the result as an identifier property to be used when comparing object instances. This helps to improve general performance, but especially performance of caching and nested results mapping, that is join mappings. ID and results attributes, each has a number of attributes. Property, the field or property to map the column results to. If a matching Java Bean property exists for a given name, then that will be used. Otherwise, MyBatis will look for a field or a given name. In both cases, you can get complex property navigation using usual dot notation. For example, you can map to something like username or to something more complicated like address dot number. Column, the column name from the database or aliased column label. This is the same thing that would normally be passed to result set.get string column name. Now we are considering supported JDBC type. Here we are considering enum constant public static final JDBC type bit. This is in the class enum class JDBC type, which is in the package.apache.ibatis.type. Now we are considering constructor. MyBatis searches a constructor declared with 3 parameters here: javalang integer, javalang string, and javalang and int in this order. While properties will work for most data transfer object, DT or type classes, and likely most of your domain model, there may be some cases where you won't use immutable classes. Often tables that can contain references or look up data that rarely or never change is suited to immutable classes. Construct injection allows you to set values on class upon instantiation without exposing public method. MyBatis also support private properties and private Java Bean properties to achieve this, but some people prefer construction injection. Constructor element enable this. Consider the following constructor. In order to inject the result into the constructor, MyBatis need to identify the constructor for somehow. The following example, MyBatis searches for the constructor declared with 3 parameters: java.lang.integer, java.lang.string, and int in this order. When you are dealing with the constructor with many parameters, maintaining the order of the arg elements is error prone. Since 3.4.3, by specifying the name of each parameter, you can write arg elements in any order. To reference the constructor parameters by their name, you can either use @param annotation to them, or compile the project with dash parameters compile option to enable use actual param name. This option is enabled by default. The following example is valid for the same constructor even though the order of the second and third parameters does not match with the declared order. Java type can be omitted if there is a writable property with the same name and type. The rest of the attributes and rules are the same as for the regular ID and result elements. Here the column name from the database or alias column label, this is the same string that would normally be passed to result set.get string column name. Java type, a fully qualified class name or type aliases. MyBatis can usually figure out the type if you are mapping to a Java bean. However, if you are mapping to a HashMap, then you should specify the type Java type is explicitly to ensure that desired behavior. Name the name of the constructor parameter. Specify the name allows you to write args element in any order. Association. The association element deals with the hash1 type relationship. The association element deals with the hash1 type relationship. For example, in our example, the blog has one author. The association mapping works most likely any other result. You specify the target property Java type of the property, which MyBatis can figure out most of the time. JDBC type if necessary, and a type handler if you want to override the retrieval of the result values. Where the association differs, that you need to tell the MyBatis how to load the association. MyBatis can also do two different ways. Nested select, by executing another map test SQL statement that returns the complex type desired. Nested results, using nested result mappings to deal with the repeated subsets of joint results. First let's examine the properties of the element. As you will see, it differs from normal result mapping only by the select and result map attributes. Property, the field or property to a map column result to. If a matching Java beans property exists for a given name, then that will be used. Otherwise, MyBatis will look for a field of a given type. In both cases, you can use complex property navigation using the usual dot notation. For example, you can map to something like something simple like username, or to something like more complicated address.street.number. Java type, fully qualified Java class name or type aliases. MyBatis can usually figure out the type of if you are mapping to a Java bean. However, if you are mapping to a HashMap, then you should be specify the Java type explicitly to ensure the desired behavior. nested select for association column, the column name for from the database or the aliased column label that holds the value that will be passed to nested statement as an input parameter. This is the same as string that would normally be passed to results.get string column name. Not to deal with composite keys, you can specify multiple column names to pass the nested select statement by using syntax column equal prop open curly brace prop equal column col1 comma prop2 equal col2 close curly brace. That this will cause prop1 and prop2 to be set against the parameter object for a target nested select statement. Select the ID of another mapped statement that will load the complex type required by the property mapping. The values retrieved from the column specify the column attribute that will be passed to the target select statement as parameter. The details example follows this table. Not to deal with composite keys, you can specify multiple column names to pass to nested select statement by using syntax column open curly brace prop1 equal col1 and comma prop2 equal col2. This will cause prop1 and prop2 to set against the parameter object for target nested select statement. For example here, that's it. We have two select statements, one to load the blog and the other to load the author, and the blog result map describe the select select statement should be used to load its author property. In other properties, all other properties will be loaded automatically assuming the column and property matches names match. While this approach is simple, it will not perform well for large data sets or lists. This problem is known as the n+1 selects problem. In nutshell, n+1 select problem is caused like this. You execute a single SQL statement to retrieve a list of records, the +1. For each record returns, you execute a select statement to load details for each one, the n. This problem could result in hundreds or thousands of SQL statements executed. This is not always desirable. The upside is that MyBatis can lazy load such queries, thus you might be spared the cost of these statements all at once. However, if you load such a list and then immediately iterate through it to access the nested data, you will invoke all the lazy loads and thus performance could be very bad. So there is another way. Now we are considering nested results for association. Instead of executing a separate statement, we will join the blog and author tables together. The result map, this is the we have already seen a very complicated example of nested associations. The following is far simple example to demonstrate how this works. Instead of executing separate statement, we will join the blog and author tables together, like so. Here notice the join as well as the care taken to ensure that all results are aliased with a unique and clear name. This makes a mapper far easier. Now we can map the results. In the example here, you can see the blog's author. Association delegates to the author results. Result map to load the author instance. Very important ID elements play a very important role in nested result mapping. You should always specify one or more properties that can be used to uniquely identify the results. The truth is that MyBatis will still work if you leave it out, and but at severe performance cost. Choose a few properties as possible that you uniquely identify the result. The primary key is an obvious choice if composite. Here the attribute result map. This is the ID of the result map that can map the nested results of this association into appropriate object graph. This is an alternative to using a call to another select statement that allow you to join multiple tables together into a single result set. Such a result set will contain duplicated repeating groups of data that need to be composed and mapped properly to a nested object graph. To facilitate this, MyBatis lets you to chain result map together to deal with nested results. For an example will be far easier to follow, and one follows this table. Now we are considering multiple result sets for associations. A name must be given to each result set by adding a result set attribute to the mapped statement with a list of names separated by commas. Here the column when using multiple result set, this attribute specify the column separated by command that will be correlated with the foreign column to identify the parents and the child relationship. Foreign column identify the name of the column that contains the foreign keys, which values will be matched against the values of the column specified in the column attribute of the parent type. Result set identify the name of the result set with where this complex type will be loaded from. Starting from version 3.2.3, MyBatis provide yet another way to solve the n+1 problem. Some databases allow stored procedures to return more than one result set or execute more than one statement at once and return the result set per each one. This can be used to hit database just once and return related data without using join. In this example, the stored procedure executes the following queries and returns returns two results. The first will contain blogs, and second contains authors. A name must be given to each result set by adding result sets attributes to the mapped statement with a list of names separated by commas. Now we specify the data to fill the author association comes in author's result set. Now we are considering collection. The collection elements work almost identically to the association. In fact, it's similar to a document. The similarities would be redundant. So let's focus on the differences. To continue with our example here, a blog had only one author. but the block has many posts. On the block class, this would be represented something like here. To map the set of nested results into a list like this, we use collection element. Just like the association element, we can use the nested select or nested results from a join. Now we are considering nested select for a collection. So you could read the following mapping like this. Let's look at using nested select to load post for a blog.
Sorry, I don't know that one.
There are a number of things you notice immediately, but for the most part of it look like very similar to association element we learned above. First, you will notice there we are using the collection element. Then you will notice there's a new of type attribute. This attribute is necessary to distinguish between Java bean or field property type and the type that contains type that collection contains. So you could read the following mapping like this here. Read as a collection of post. In an array list of type post. The Java type attributes is necessary. Java type attributes is really unnecessary, as MyBatis will figure out for you in most cases. So you can just shorten this down simply like here. Now we are considering nested results for collection. Now mapping a blog with its collection post mappings as simple as here. By this point, you can probably guess how nested results for a collection will work, because it's exactly the same as association, but the same addition of type attribute applied. First, let's look at the SQL. Again, we have joined the blog and post tables and have taken care to ensure quality result column labels for simple mappings. Now mapping a blog with its collection of post mapping is as simple as here. Again, remember the importance of ID elements that are here, and read the association selection above if you haven't already. Also, if you prefer a longer form that allows more user reusability, of your result map, you can use the following alternative mapping. Now we are considering multiple results for a collection. The name must be given to each result set by adding result set attribute to mapped statement with the list of names separated by commas. As we did for the association, we can call the stored procedures that execute two queries and return the two results sets, one with blocks and another with posts. The name must be given to each result set by adding result sets. Attribute to the mapped statement with all list of names separated by commas. We specify the posts collection to be filled out of data contained in the result set named posts. Note there is no limit to the depth and breadth of combinations of the associations and collections you can map. You should keep performance in mind when mapping them. Unit testing and performance testing is your application goes long way towards the discovering the best approach for your application. Nice thing is that MyBatis let you to change your mind later with very little, if any, impact to your code. Advanced association and collection mapping is deep subject. Documentation can only get you so far. With a little practice, you will become clear and very quickly. Now we are considering discriminator. For example, here sometimes a single database query might return result set of many different but hopefully somewhat related to data types. The discriminator element was designed to deal with this situation and others, and including class inheritance hierarchies. Discriminator is pretty simple to understand as it behaves much like switch statements in Java. A discriminator definition is specified column and Java types attributes. The column is where MyBatis will work for the value of the to compare. The Java type is required to ensure the proper kind of equality test is performed, although string would probably work for almost any situation. For example, here in this example, MyBatis would retrieve each record from the result set and compare its vehicle type value if it matches to any discriminator cases, then it use the result map specified by case. This is done exclusively. So in other words, the rest of the result map is ignored unless it's extended, which we will talk about with extent. If none of the cases match, then MyBatis simply uses result map as defined outside of the discriminator block. Now we are considering auto mapping. In the following sample, ID and username columns will be auto mapped and hashed underscore password column will be mapped. As you already seen in the before, in simple cases, MyBatis can auto map the result for you and others you will need to build a result map. But as you will see in here now, you can also mix both strategies. Let's have a deeper look at how auto mapping works. When auto mapping result, MyBatis will get the column name and look for the property with the same name, ignoring case. That means that if the column name ID and the property name ID are found, MyBatis will set the ID property with the ID column name. Usually the database columns are named using uppercase letters and underscores between words, and the name properties often follow the camel case naming. To enable this auto mapping, between them, set the setting map underscore to camel case to true. So here the mapping here going there, and this one. Auto mapping works even when there is a specific result map. When this happens for each result map, all columns that are present in the result result set have not a manual mapping will be auto map. Manual mappings will be processed in the following sample ID and username columns will be auto mapped here, and hash password column will be mapped. There are 3 auto mapping levels. None disables auto mapping, only manually mapped properties will be set. Partial will auto map results except those that have nested result mapping defined inside joins. Full auto maps everything. Now we are considering type aliases in configuration. Annotation interface aliases, the annotation that is specify alias name. This is in the package org.apache.typebatis.type. A type alias is simply a shorter name for Java type. It's only relevant to the XML configuration and simply exists to reduce the redundant typing of fully qualified class names, for example here. With the configuration, block can now be used anywhere. Domain blog could be. You can specify a package where MyBatis will search for beans, for example here. Each bean found in the domain.blog, if no annotation is found, will be registered as a alias for alias using uncapitalized non-qualified class name of the bean. This is domain.blog. Author will be registered as author here. Simple with simple author like here. And if alias annotation is found, its value will be used as an alias. See the example below here. Now we are focusing on primitive or simple. Int, string, date, etc. Int, these are as outputs. Int, corresponding Java type is java.lang.long. Corresponding CLR type is system.int64. String, Java type is java.lan.string. CLR type is system.string. Date, Java type is java.sql.date generally. CLR type is system.datetime. As an example, we can consider this. Here in the int, here corresponding Java type is java.lang.long. As an example 2, we can consider this one string. Here corresponding Java type is java.lang.string. As an example 3, we can consider this one. The corresponding Java type is java.sql.datetime generally. Here date. And now we are considering type handlers. Here's a Boolean type handler. This is in the Java types. For the Java types, java.lang.boolean and Boolean, simple Boolean. JDBC type, any compatible Boolean. This is in the class Boolean type handler. This is in the package org.apache.ibatis.type. Now we are considering type handlers. For example, here the interface mapped JDBC, the annotation interface mapped JDBC types, the annotation that is specified JDBC types to map the map type handler. This is in the package org.apache.ibatis.type. ibatis.type. Whenever MyBatis sets a parameter on a prepared statement or retrieve a value from a result set, a type handler is used to retrieve a value in a means to inappropriate to the Java type. You can override the simple type handlers to create your own to deal with unsupported or non-standard type. To do so, implement the interface org.apache.ibatis.type handler or extend the convenience class org.apache.ibatis.type base type handler and optionally map it to a JDBC type. For example, here using such a type handler would override the existing type handler for Java string properties and varchar parameters and results. Note the MyBatis does not introspect upon the database metadata to determine the type, so you must specify that it's a varchar field in the parameter and result mapping to look to hook the correct type handler. This is due to the fact that MyBatis is unaware of data type until the statement is executed. MyBatis will know the Java type that you want to handle with this type handler by introspecting its generic type, but you can override this behavior by two means: adding Java type attribute to the type handler element, for example Java type equal string, adding map type annotation to your type handler class, specifying the list of Java type associated with it. This annotation will be ignored if the Java type attribute has also been specified. Associated JDBC type can be specified in two means: adding a JDBC type attribute to the type handler element, for example JDBC type equal varchar, adding mapped JDBC types annotation to a type handler class, specifying the list of JDBC type associated with it. This annotation will be ignored if the Java type JDBC type annotation has also been specified. By deciding which type handler to use in the result map, Java type also known from the result type, but the JDBC type is unknown. MyBatis therefore uses combination of Java type equal the Java type, JDBC type equal null to choose a type handler. This means that using at mapped JDBC types, Annotation restrict the scope of a type handler and make it unavailable for use in result map unless explicitly set. To make the type handler available for use in the result map set, include a null JDBC type equal true on the mapped JDBC types annotation. Since MyBatis 3.4.0, however, if a single type handler is registered to handle Java type, it will be used by default in the result map using this Java type, that is even without include null JDBC type equal true. MyBatis-config.xml example type handler Java. For example, we can consider this: could not set property output of a class java.land.integer with value 55 cause org.apache.ibatis.reflection exception. There is no setter for the property named output in class java.land.integer. Now we are focusing on RDBMS, a database management system, DBMS, based on the relational model. Here you can see how does it work. The iBatis data mapper framework will help you to significantly reduce the amount of Java code that you normally need to access the relational database. iBatis simply maps the Java beans to SQL statement using a very simple XML descriptor. Simplicity is the key advantage of iBatis over other frameworks and object-oriented mapping tools. To use iBatis Java Mapper, you need to be familiar with Java Beans, XML, and SQL. There's very little else to learn, and there's no complex scheme required to join tables to execute complex queries. iBatis Data Mapper API allows programmers to easily map Java Beans object to prepared statements, prepared statement parameters, and result sets. Philosophy behind the data mapper is simple: provide a simple framework to provide 80% of JDBC functionality using 20% of the code. This is how does it work. Data mapper provide a very simple framework for using XML descriptors to map Java beans, map implementations, and primitive wrappers using string, integer, etc., and even XML documents to an SQL statement. Following is the high-level description of the lifecycle. Provide an object as a parameter, either a Java bean, map, or primitive wrapper. The parameter objects will be used to set input values for the update statement or where close values in a query, etc. Execute the map statement. This step is where the magic happens. The data mapper framework will create a prepared statement instance, set any parameters using the provided parameter object, execute the statement, and build a result object from the result set. In case of the update, the number of rows affected is returned. In case of a query, single object or collection of objects is returned. Like parameters, return objects can be a Java bean, a map, or a primitive type wrapper, or XML. Here you can see an example code here using Java ORM with PostgreSQL. The named file is MyBatis-config.xml here. Here you can see the driver value org.postgresql.driver here, and URL is here. Here the as an example 2, we can consider this one. The environment element define how the environment is configured. Notice the key sections here. The default environment ID, for example, default equal development. The environment ID for each environment defined. So this is the default environment ID, and this is the environment ID for each environment defined. The transactional the transaction manager configuration, type equal JDBC here. Data source configuration, type equal pooled. Default environment and the environment IDs are self explanatory. Name them whatever you like, just make sure the default matches one of them. Transaction manager, there are two transaction manager types, that is JDBC and managed, that are included with MyBatis. Here JDBC, this configuration simply makes use of JDBC commit and rollback facilities directly. It relies on the connection retrieved from the data source to manage the scope of the transaction. Here you can see the data source. The data source element configures the source of JDBC connection object using the standard JDBC data source interface. Most MyBatis applications will configure the data source as an however, it is not required to there are three built-in data source types: unpooled, pooled, and JNDI. Here is pooled. This implementation of data source pools JDBC connection objects to avoid the initial connection and authentication time required to create a new connection instance. This is the popular approach for concurrent web applications to achieve the fastest response. Here you can see driver property name. This is the fully qualified Java class of the JDBC driver, not of the data source class if your driver includes one. URL, this is the JDBC URL for your database instance. Username, the database username to log in with. Password, the database password to log in with. This is a sample SqlMap.config for .NET web application. Place this file in same directory as web.config. Here you can see database, provider name SQL Server 1.1, data source name npet shop, connection string here, password here, data source here, database here. As an exception example, we can consider this: org.apache.ibatis.exceptions, persistent exception, error querying database, cause java.sql.sql syntax error exception, etc. As an error example, we can consider this: you have an error in your SQL syntax, check the manual that correspond to your MySQL server version for the right syntax to use near create temporary table temp underscore role underscore id int insert into temp underscore role underscore id va at line 2. This is end of my presentation. Thank you very much for watching it.